Hello, everybody. Am I live? Is it working? Is it working? It is working. I can hear myself. Fantastic. I'll pause that and minimize. Well, actually, not do that. Welcome, everybody. Welcome to the stream. It's another Lenser stream. Let me make my announcement. Be sure to join the Discord in the description below to get every announcement every time I go live. You will be notified, especially if you ask to join the Notifs group in any of the channels. Can't believe this is part 62. That's incredible. Okay, so part 62 is going to be, I don't know. It doesn't need a title. Who cares? Cool. We made our announcement. We are now officially live. Welcome, welcome. Rohan says waiting for part 69. Wink. Oh, yes. We'll have to have a celebration. Beaver Fever, hello. Sarade with a yep. I'm thinking about doing a VC stream. How do y'all feel? I'm thinking that's the way to go about things. So I'm gonna pop in the VC and we're gonna see how it goes. Let me remember how to do things on Discord again. I'm good at forgetting. Okay. And hopefully this is fine. Hey, it's local. Hey, it's Sarade.
Hello. Oh god, I gotta mute your stream. Oh no. Here we go.
Tazon Day moment. Ryan says, if I knew what VC stood for, sure. It is voice channels. Voice channel. Voice chat.
But sure.
To me, I have like a TeamSpeak is where I came from. So I have the user joined your channel. So it's always a voice channel.
User disconnected.
Yeah. Instead of the that Discord does. It mimicked Skype in that regard.
It mimics not being all that verbose and letting you hear people talk.
Yeah, but that's no fun. Who likes to listen to your friends?
Yeah. You don't need to actually hear voices in voice chat.
Yeah.
There's the endless spam of user joined your channel, user left your channel.
That's the true peak of human communication. Megit has taken a while to happen. It's been a while. So I just have to fetch remotes. We have a wonderful pull request to merge. What am I doing? I gotta open GitHub. That's what I'm doing. Blink. Where are we at? That's right. Sorry, do you wanna introduce this?
Sure. As we can see, what I did here is I removed a tautological condition of an if statement. That's the PR.
That is the 24 files change. Oh, it's from one commit. Here. That's better. That's better.
There we go. You can read the list of changes yourself. It's pretty comprehensive. Except for I forgot to add one thing. 1 second. I'm going to add that to the comment real quick because this is very important.
The live refresh.
Testing
GitHub's database and CDN caching.
You guys over here doing work, me eating cookie dough.
I'm drinking like sugar water.
Ooh.
Balance. There we go. Very important point.
That is. What'd you say, local?
I said that's most things in America, sugar water.
It's true.
Emphasis on the sugar and lack of water.
Yeah, it's apple juice. It's basically just sugar.
Okay, that's more water than not.
I don't know.
It's a lot of water.
So this is incredible. We have NVP in Maine, it now looks like. That's fantastic. So the argosy is always assigned 32 integer.
Unfortunately, hold on.
It may not be like that anymore.
I think I set it to int. I forgot.
I
the
see.
return value is still integer because changing that to int breaks horribly in like the Cogent backend somewhere.
Yes.
But this might be a typo. Hold on.
Okay.
Let's see, where the hell is the thing? Here. This would be in here, down here. Let's see. No, it isn't. Is in fact it's a C int, not a S32.
Nice.
It is
Okay.
a
Okay.
C int. Currently, a C int is always an S32, so that's probably what I meant.
That makes sense. That makes sense. Yeah,
There we
because
go. Fixed it.
legendary. Sweet, sweet. And C int is just like CFFI types.
Internally, that's that's not
Nice.
exposed to the front end, so you can't actually type C int and have it compile it yet.
It's
But
not a keyword
internally,
or anything. Yeah.
more or less a thing for that yet. It's not fully propagated, and it's also very much not. It's currently it does do long correctly on Windows as opposed to Linux, but it's not really used everywhere. And the thing is that it's in particular it's not used in Semma. So if we added size of operator, it would be incorrect. That's why we haven't added cint yet to the front end, because we still need to, like, for that to work, we basically need to create the code gen context earlier on and also use it in Semma. And actually what I would suggest is just converting that from code gen context to just the context for everything, because Semma also needs to know what target we're compiling for to know what the size of a long is, for instance. So we need that early on.
Yeah, you've got to do earlier than code gen target information. I still haven't figured out where I'm going to put that in mine. It'll probably all get constructed before the parser.
Oh
just
no,
in order
you got all
to-
of my branches. Oh god.
You.
I have no idea what most of those are except the LLVM branch. So
You said you have no idea what you're gonna do with the parser
No,
what
I
the
think I'm
IR
gonna,
path.
local.
What do you mean?
I
Oh,
was going to figure out where I'm doing that kind of platform specific stuff for like platform specific type sizes. It'll probably just be a lookup table, so before parsing even, but I have no idea.
Yeah.
what I'm gonna do for my language, I'm just going to call into LLVM and get the target machine and then use that.
Yeah. If I end up with LLVM, then I will do the same. If I don't, then I don't know.
Depends on, because you're using C, I'm not sure all of the target machine stuff is really that exposed to the C API, but because the C++ API has it, of course, but I'm not sure about the C API. I'd have to check, because the C
Yeah.
API does support a lot of things.
I may have to write my own C API if I want to use LLVM like that. How much of that can I get just off the CLI? I imagine not much.
It's /LLVM.
Thank you.
That
Oh no, what have you done?
that's fine, because it's a branch that's not part of your repository. That's why it's complaining. This is fine.
Oh, it wants me. Okay, hold on. I know what it wants me to do. So okay, it's gonna
You can
be.
git branch. Oh no, you can do
think-
something. I don't know.
I think I'm gonna have to do this again. Now
Git.
yeah, now it's no longer screwed up, and then I'm gonna get branch here. There we go.
Oh, I see.
Because I have to create a local branch copy. So now if I do list, see now I have this as an actual branch that I should be able to switch to, right?
But it doesn't look like your commit has changed.
Did that not do the remote?
No, I don't think that did the right thing.
Why?
I think you just created a branch called that.
Why? Then what am I supposed to do? It
was
yells at me if I check
what
out.
you did before was right. A detached head state is not an error. It's a valid state if
Why
you know how to
then it
deal with
shouldn't
it.
give me a
No,
giant
that's
warning?
just because people don't know how to get back to. They don't know how to get back to. So just go back to your branch, check out your branch, and then check out my branch, and it just works.
Ugh.
And just calling git branch like that is a bit sus. I have no idea what that does actually.
Really?
I have no idea what calling git branch on
Have
its
you-
own does.
Well, do you
always just
use the
press
command
something
line?
else. I use the command line, but I never do git branch. The only thing I do is git branch D for delete. That's the only thing I do with git branch, or maybe git branch, I think, rename. No, that's something else entirely, I think.
They did
Oh,
both
dear.
versions
And
for it.
git branch alone, I don't really use it for anything.
Interesting. I use it all the
Git
time.
branch M, git branch D, there we go, that's what I use. Or git
Yeah.
checkout dash P to switch to a new branch and create it. But for switching branches, I've never used git branch for that. I've no idea whether you can do it with that.
I
Yeah,
know
you have to
check out.
create a local one, and then
I would
that
just do
mirrors
git
the
check out
remote.
my branch, then we're in a detached head state. That's not a problem.
Okay, I gotta
That's a
read chat.
valid state. You know to deal with it because you can check out. You can
I gotta
check
read
out any-
chat. I see Guild Wars 2 pinned to the taskbar. You gotta play some recently? Yes, I've been playing Guild Wars 2 recently. I haven't had
Oh,
a ton of time, but I have. First time chat from Alex Dev. We got, hi, compiler from scratch. Why would you do that?
Fun.
Fun. For
You
fun.
forgot the for fun part. You guys talk about for fun. I'll be right back.
Okay.
Sure.
And then, but true, just one time does system for fun. I have no idea what that means. But good project. Thank you. I appreciate it. Handling multiple remotes in Git is always scuffed. What were you saying, Saraid? I'm sorry I cut you off.
What I was saying is just switch to my branch and leave it at that. A detached head state is not an error. It's what happens if you check out a commit, and that commit isn't really the head of a branch. That's what happens if you do that. You can do that. That's fine. If you know to switch back, you can switch back by checking out the branch and doing git switch dash. So just check out my branch and that's it basically. You don't have to do anything else.
Basically.
Okay. I'll trust you on that one.
Trust.
Oh,
But
God.
now you have a local branch, so you need to delete the branch you created locally because you've called. Yeah.
You know, the easiest thing to do.
No, God. No, don't do that. We
Why
gotta
not?
fix this problem. Jesus Christ.
It's a fresh poll. That's literally the point of it.
Okay.
And then here's the thing. I'm just going to poll yours.
That's yeah, sure.
It's a dumb solution, but it will work.
You're gonna fill up your drive again.
Yes. I'm actually doing better now.
Hmm.
Slightly.
Well, that's a lot better than what I saw last time, I think.
Yeah, and this is actually organized, which is fantastic.
I see.
I still got to work on it. Oh, it's
By
probably
the way,
sleeping.
Jesus Christ. As a rule of thumb, by the way, I generally disconnect backup drives because if you get ransomware on there, it will also infect the backup drive if it's
Well,
connected.
I'm
And
still
if you
doing
mess
the
up in
backup.
WSL
dude.
and rm/rf root, it will also delete everything in external drives. So
Yeah, I just don't do that. Simple as.
Right.
let's not make any mistakes. That's a good idea. Let's start with that.
It is that
Yeah.
simple. First time chat from Uchinara Konoha. Oh my god, you're making a compiler, PogChamp. Thank you. Yes, we're making a compiler. What's your editor of choice? The only editor, Emacs. It's at least Doom Emacs? No. It's a custom config. You can find it on my GitHub. It's not Doom Emacs. We like
Every
the
time you say do me Max, I just hear do me Max. Do me.
Doom Emacs.
I don't know who Max is, but Max. I was thinking CS because but Max is just a name. Fuck, let's go. It worked.
Why do they not exist? Am I crazy?
You have to fetch.
I did fetch.
Just do checkout LVM. Git checkout LVM.
It's just so
There,
scuffed.
done.
Switch to a
Would you
new
look at that?
branch.
Now you can build that.
That's new. It was Serraid Slash.
No, wait, he cloned my repo.
Yeah.
Yeah,
I-
but isn't the branch name the same?
This is my repo. The branch
So-
name is LVM.
Yeah, what I tried to do before was add a second remote of his repository on top of my remote. So I
which is
had
what
like
I've-
origin main, and then I had like Serraid blah. So I was trying
I
to do
had the
stuff on a
same,
different
except
remote,
it's origin and upstream for me because yours is upstream.
which is really easy to do. Yeah, if you're that direction is like built into most Git things, but the other direction is just like, figure it out.
Mm-hmm. All right, let's try and build it, shall we?
I think I just do something like this.
Sure.
I wonder if I can just here. Let me just search for CTest. There we go.
I was fixing one
yeah.
error and then 10 more show up.
Let's save this for 1,000 Windows. I haven't actually tested that.
What have I done?
Not that this is of any importance to you right now, but the oh yeah, apparently these aren't fixed. Interesting. Is that because you? Oh, it's because it might be a long thing.
It's definitely a
Interesting.
long thing.
What is this conversion from file system to? Did I do native or something? Oh, what is this? Hold on. Is this because your G is probably because your GCC is too old or something? Let's take a look at that, shall we?
You
hold on.
changed the test runner?
Yeah, of course I fixed it. It was horribly broken on Linux because you were using system incorrectly.
Well, now it's horribly broken on Windows.
It's broken in one line, line 221. What is this? It's I'm looking at my compiler. But not even, I'm looking at something completely different. That's an easy fix though.
What is it complaining about?
It's complaining about some conversions, and I know why. It's just being annoying. We can fix that by just not using a ternary operator here, probably. So if this thing is absolute,
I see.
then set test invocation to this, and this is a path, so we call string. Else we do this, and we wrap it in this. Actually, we can probably just call string and call it a day. Yeah, that should do the trick. Yeah. Paths are weird in Windows because they're wide strings internally. That's the thing. So we can just do this, and that should do the trick. There we go. We can even format it nicely. Would you look at that? So this should work.
I'm curious to. I followed along.
The wrong terminal. Hold on.
Where did you send it?
No, that probably doesn't. I mean, that might fix it. My solution would be this. Hold on.
The suspense is killing me. What did I do wrong?
Also, petition. Can we rename the goddamn test folder to TEST because it's driving me mad?
No. If we're gonna do that, then we're gonna rename the source folder SOURSE. CE. I can't even spell.
TST. Everyone calls it SRC.
Well, everyone calls it TST and everyone calls it BLD.
I've never seen TST.
I still want to rename docs to doc.
Fix.
And then I was gonna rename this to edit, and then maybe have docs and edit.
Hopefully fix. Path to string conventional Windows. There we go. Let's try now. We can pull now. Like discard that and pull now.
Yes. Where are we? Phantasmo. Yes. Is that gonna work?
You should do git restore dot never star, but sure.
What's dot?
The current directory.
Oh, so it just does everything in the okay.
Yeah,
I just do star because that's also
running git restore on the .git folder is a good idea. Not that it's probably going to do anything. Anyway, it's also not in source; it's in test.
Why did that not
so
work?
Git restore dot is what I do. There we go.
I always do ls instead of git status. I have to get in the habit
we
of
go.
stopping git polling. Git poll is for fetching and merging. All I need to do is merge if I've already fetched it. I need to get in the habit.
You could also just rebase. That's better than merging.
Well, git merge now automatically does that.
You've set it to rebase. Okay, I haven't. That's why. I
Yeah.
just do rebase.
It has an automatic.
Yeah, I know it does.
Yeah,
I just haven't set it to that.
that's fair. It did. I had to do the user config thing.
So there we go. That should hopefully fix it.
This should fix it.
Yeah, the problem was it wasn't being converted to a string. Dot string does that, so it should fix that, I hope. Unless the problem is concatenating two paths, which I doubt,
Yeah,
because
that
that
should
should
be
just
fine.
work. If there's another problem in this file, then we'll keep going like this. But it should have reported that because it's actually a competent compiler. Most of the time.
Uchinara Konoha says, Lamau, could you make a vote TST or test? Lol. I'll do it.
Yes.
This is why I need a moderator. TST.
You can make me a mod if it helps.
Let's do it. Anyone who wants to be a mod, I'll make you a mod. I don't know if that.
Gimme.
Agma's Twitch channel, on which he's streamed exactly twice in his entire career. So I have, I'm qualified for this. Yeah, that's about expected, I think. I don't think that broke anything. I mean, basic references 3 is broken, but I have no idea what's going on there. But 3 tests are broken. That isn't half bad, I'd say.
It's not too bad. What do we have going on? Okay, so that's an object file backend thing, most likely. I think this is the 3 tests that were. What is basic references 3? Is that new?
I have no idea.
Okay, I feel like that's new.
Basic references 3 is interesting.
This doesn't work.
Fascinating.
A is a byte. B is a reference to a byte. Return B. What's it returning? Okay, now I'm curious.
I changed anything in Sema except like the parameter of main that we weren't using anywhere. I think that's it.
I see.
I know there was something else in Sema that was weird, I think. Oh, comparisons now return integer. That's also something I changed.
Instead of just like whatever the binary was.
Or if you were comparing 2 pointers, it would return a pointer.
Did we... How smart is our test instantiator?
I have no idea.
Should probably find program Clang. Okay, so I probably need to use Clang to compile this for this to work, huh?
Wait, hold on. Yeah, you need to use Clang for it to build the LLVM tests.
Okay, let me think about
and enable the LLVM tests.
Let me think about
so just set DC make CXX compiler. Either that or set an environment variable like CC equals Clang and CXX equals. I think C compiler and CXX compiler, but I'm not sure anymore.
Yeah, and I just need to do Clang because it's in path.
Yeah, but I'm not sure whether that works the way, whether you need an absolute path though for this. You could try setting CC and CXX.
Build files cannot be regenerated correctly. What happened?
Oh, this is this is a problem that it sometimes has. Try doing that. Maybe that'll work, or it will enter an infinite loop. We'll see.
I like infinite loops.
If you mess up using these variables like CMake CCompile and CMake CXX compile, the way this interacts with the cache is weird. If you modify those in a sub-project, it will just rerun itself over and over again. CMake will just enter an infinite loop.
What the fuck?
You mess up there. It found LLVM 12. Okay, fascinating. It's trying to compile the format check plugin, but your LLVM version is too old for that.
That's stupid. It's not a stupid plugin, but it's stupid that LLVM has all these stupid requirements for I downloaded 14 times.
I should probably add a version check to this for what version we need. But let's just say do like, I don't know, either comment that out or something, or just do.
So what is LLVM package version actually?
LLVM package version, it just checks if it found it. That's the full version. I think you need version major. I know that I can check my compiler because it uses LVM
So
to tell you how to check the major version. I think you need at
Or-
least 15 or 16 for this. I think it's 15 is like the minimum you need for this to work.
I see.
LVM 15. Otherwise, forget about it. Also
have
about
15.
compiling the generated IR, by the way. It's finding 12. Find packages finding 12, unfortunately. So you can do this. You can do this in CMake. I'm going to post this in. Where should I put
Fantastic.
this?
A general or like the voice channel general or
Yeah, I'm just going
DM
to put
or
that in here. So
anything.
you can do this. And then if this is true, just an error or something, or not do it.
Fantastic.
Because we need at least 15. The format check plugin, I'm not sure. 15 should be enough for that because I think AST matches were introduced in 13. But for the generate IR, you need at least 15. I've only tested it with 16, by the way. So
And a thing.
yeah, you should probably be able to do greater if it's the opposite of less. Because we don't want to do that if it's less. So
I
we
see.
want to do
So
it if it's
yeah,
greater.
I see what you're saying. And then the idea is we message fatal error.
Yeah, well, now you can't compile with Clang at all is the problem because this is the format check plugin.
Ah. Okay. Yeah.
So
So we do just
need
have
to
to
do
do
that. With this if you can probably do and probably it's greater. You can probably do greater. Let me see. CMake.
I mean, we need greater than or equal.
Greater.
It's also you can just change the constant.
14. Oh, there's literally. Do you know how you spell greater or equal to? You spell it like this. CMake. Best language ever.
Oh my. Okay.
Or is it greater equal to? No, it's greater equal. My bad. It's greater equal. Greater underscore equal. Next time, okay, for future reference, copy from the Stack Overflow answer, not the question.
So if
Greater
defined
equal apparently
the
is it
impact
would be.
version major greater equal 15.
If that's true, we add the format check plugin we compiled and so on. We might have to do that further down because here it's compiling the format check plugin because it needs to be compiled at configure time so we can load the plugin when we configure the compiler itself, because if it's not there yet, Clang will complain if we try to load a plugin that doesn't exist yet. So because of that, we need to build the plugin before we're done configuring the compiler. It's scuffed, I know, but this is what a CMake maintainer recommended on Stack Overflow when asked the same question. How do you build stuff at configure time? It sucks. Is the answer. It sucks.
So Alex Dev says, do you have Emacs Pinky? No. I have an ergonomic keyboard and I have a key map layout that my pinky doesn't bend abnormally. It's basically on the home row at all times. Because my control key is here. Or here with my left thumb. Or here with my right thumb.
I was going to say it's caps lock, but not even. That's not even, you can't even really say that about your keyboard.
Yeah. It's sort of where caps lock would be.
It would normally be doesn't apply here. By the way, this if actually handles everything related to the plugin. So it also adds it to the command line. So all of that is handled already. Like the line 106 adds it as a command line argument to int-c. And this will error if the file doesn't exist. So that's why we need to compile it first. That's why all of this nonsense exists here.
Okay, so yeah, no Emacs Pinky. My Emacs is great. My Pinky's great. Rohan says, soon TM we get into coding. Git is just holding up things as usually. Yes. I use Git desktop 100% of the time. Is it bad? It's not bad to use a GUI solution to a complicated problem. Git is complicated, and if you just need simple solutions, then Git desktop is like fine.
What I found is that for most things like committing and adding files, I'm usually faster for doing it on the terminal. But what I do absolutely use UI for is merging, because not having one sucks.
Yeah, having a diff UI is amazing, like edif in Emacs.
Also, the IntelliJ platform diff UI is pretty good. You can also just diff any two random files. That's pretty nice. So let's see how this goes now.
It's trying.
All of the LVM tests are going to fail horribly, just so you know.
Why?
Because if depends on your Clang version. If this is Clang 12, it's not going to work. It has to be at least Clang 15, I think.
This should be Clang
So-
15.
Apparently, it is working. Would you look at that?
Hey.
Because find package is just being weird then. Because the thing is, what I've found is that find package is a misnomer. It should be called like load package. Because for find package to be useful, you generally need to specify where to find it. Otherwise, you will find the wrong version.
Beaver Fever says, not necessarily you have a lot more control with the CLI, but the desktop can still do most of the things you'll probably need. Yeah, basically that. Not Sword 1 says, DCS, hello there, how we doing? We're doing good. We're writing a compiler for fun. That's actually not too bad. A lot of these are why are these failing now though?
These were also failing before I started the thing.
So these are just
So-
failing under Clang.
No, ASM is just that could just be that could very well be the case that they're failing on the Clang, yeah.
Yeah, because
But
there's
those
only
were
3
failed for a
tests.
start, I'm pretty sure.
There's only
Those
3
were-
tests failing under GNU.
So also before we look at the generated IR for this, I'm not sure how familiar you are with find package, but I guess I can put it in Twitch chat if anyone's interested. What you can do is you can, for instance, if you want to do find package LLVM, you can define this on the CMake command line, and then the find package will look for it in there and load it properly if you have the right LLVM version in a specific directory. Because if you don't do that, it will just find the wrong one very often. So again, find package is a bad name for it. It should really just be called load package on the slip.
That makes sense, yeah. And find package, doesn't it just use like the modules in the it just uses like the CMake files that come with the
Yeah.
CMake installation. And you can like write your own.
I'm not sure it's with a CMake installation, but it's like there's some CMake module path and it finds it in like certain predefined directories or however
Yeah.
that works. I'm not exactly sure how it works exactly, but what I've learned is that if you want to use a specific version of LLVM with find package, use find package to load. Don't try and load LLVM manually. You will fail horribly. Do not try to link or load in LLVM manually. You will fail. Use find package and point find package to the right connection. To the right. What is a connection? I've been doing too much web development stuff. To the right directory is what I meant.
That makes sense. I was a little confused. I was like, to the right connection. Ooh.
Yeah.
Were you
Because
connecting in
someone's
that?
asking, this is a public collection of tests for compilers insofar that it's on GitHub, but we wrote that. So
It's written in our custom language
a public
intercept.
test collection for this compiler, if you will.
That's right. But yeah, it's just ones we've written. And
Mhm.
currently we're using ctest to run different batches of tests. So we have like the tests running under the assembly backend, which passes, as you can see here, I'm sure, somewhere. We're running our built compiler, and then we're passing a bunch of like, the assembly backend and giving it a file and stuff to compile.
Mhm.
And then
Right, now you,
for the
Oh, sorry.
LLVM one, I was just going to point out the target. The only thing that's different is this little somewhere, if I can find it. Oh boy.
you were already at one, but you just
Oh,
kind of. Oh no!
you have made mistakes.
Oh god. Okay, let's not look at that.
UB.
You were already looking at it when you just scroll past it. It was below the one you were pointing out.
Oh, that's funny.
Just slow down.
Oh,
Stop here. There we go. Yeah, TLVM now.
but yeah, basically, so the
It ends in .ll now, the output file, because that's the file extension for text LVMIR.
that's right. But yeah, so we're running different backends for our custom compiler to test like how they perform and if there's bugs in them. It's end-to-end
what-
testing.
Yeah, so what you can try now is grab any random test and run the compiler manually to output LVMIR, and then you can take a look what it outputs.
Okay. So I'm going to be doing build int
So that'd be
c.
interesting.
Let's do.
Test or example or whatever.
Let me think about this. Maybe while.
Sure.
I feel like that'd be a good, fun one.
So we have to TLVM for this. And the calling convention, I think you don't have to input anything because Clang can figure that out. Because we're not dealing with that anymore manually in the LLVM backend, at least.
Oh dear.
And there's an output path I would specify like .ll, otherwise.
Yeah, I'm kind of. That's fine.
Oh,
I'll
it does
put
it automatically. Interesting. I think I did that. Yeah, in main, I think there's some check where it determines the default. No, yeah. You know, we can take a look at that. It's just text.
Okay. Cool.
Mm-hmm.
Okay.
Ooh, over my arm.
Oh no.
There we go. Nice, isn't it?
Ooh.
Oh dear. Okay, so. Oh, Dwar's here.
Hello. I'm back.
Hey, it's so good to see you. So, oh god, there's so much in chat I missed. Uchinara Konoha says, "Make me a mod. We'll be here twice a year." By the way, I tried to make a poll earlier, and Twitch kept giving me a 503 service error. So
You can try making me a mod, and I can try it.
legendary. That's a good idea.
Same. We will compete.
Beaver Fever says, "I would say I would take it, but time zones love does not allow me to see the stream." Yeah, I understand. Virlius, real programmers know that greater than or equal to is spelled .ge.
That's a Fortran thing, in case you don't get the reference.
Oh my gosh.
That's how you do it in Fortran.
Uchinara Konoha says, "Oh my god, you're one of those." That was probably in response to Emacs something. Or no, that was the split keyboard, I'm sure.
Oh, I see. Yeah, probably.
Rohan, we're doing good. Failing everything. Yep. And then, yeah. You're compiling what, by the way? That's a good point. Here, let me load the file that I need to load. We are compiling intercept. Here, I'll open the actual file we're compiling.
Nice.
This is the file we're compiling. Intercept is a compiled language, and it's basically, it's just where it's getting there. It's not really fully feature complete. We're working on modules right now, and we're merging an LLVM backend currently. Yeah, it's a multi-platform compiler and hopefully eventually multi-language. It's going to be a Lisp here soon, right?
What? Actually?
That's the plan, a
Oh my,
Lisp
know that.
front end.
damn.
It should be pretty doable. What does discardable mean? Great question, Verlio. So currently it's slightly scuffed because there's this ancient thing that I did a year ago, Ext, that I did to make things work, and we're currently trying to phase that out in terms of new attributes. So discardable is a function attribute, and the idea is that you can put as many function attributes as you want following a function signature, and they're like contextual keywords. So discardable is a function attribute that means that putchar does return a value, but you don't need to handle it or do anything with it. It can just be thrown away and thrown away. Because most of the time you don't need the return value of putchar. And the reason we're doing this is because in languages like C++, the default is to have everything discardable, and then you have to say no discard. But that just means that if everything ends up with no discard.
Not everything, but a lot of things. And generally people argue, or there's a lot of people that argue, and I would also argue that no discard should have been the default. And people like Herb Sutter has made that the default in his CPP front compiler. So making that the default is a sensible thing to do, because if you have a return value, you should probably use it. That's why, otherwise it should just return void. And in cases where you might not want to use it, then that's what this is for.
Exactly. There is another alternative solution. If you implement a discard operator sort of in your language, if you say the keyword discard and then the expression, then that's and then you can totally lie.
Something like that, or a cast to void is also an option. Yeah.
We were gonna do something like this.
Yeah. That's
could-
also an idea, for instance. But you,
Yeah, I was going to introduce the discard
every
keyword.
time
as
you
well.
use putchar, that's why we have this.
But yeah, a
Because-
discard prefix could work.
If you call
That's what I'm
if you
doing.
call printf 37 times, most of the time people won't check the return value of printf. So
Yeah, good point.
you don't want to write as void or cast it to void.
Yeah,
37
that's
times,
gonna
that will be annoying.
okay.
So
That's what multi-carat editing and copy pasta is for.
well, that doesn't work like everywhere across the code base. Oh god. But isn't there an LVM mode for Emacs, by the way?
I may have to. Well, this Emacs config moment. Perfect time to add another language to the list. Do you know what it's called?
Maybe
Is
I
it in
do both
Melpa?
then.
I think it's in the LLVM repository. Perhaps there is one. I wouldn't be surprised if there was one. Let me check the official LLVM repo because they might have one. They might have an Emacs mode.
Here, let's.
So I just need to find it because I
This is
know
perfect.
they have one for MLIR. They have one for MLIR. I'm not sure about LLVMIR, but I would be surprised if they didn't. Let's see. I can probably just search for like .el or something.
There's not one in Melpa, which is surprising.
Interesting. There should be one somewhere. I know. Emacs list. There we go. LVM MIR mode. Emacs.al. Oh, this is for C mode. Okay, let's see. I'm currently looking through MLIR
Who are
mode,
you?
MLIR mode.
I think I found one
LVM mode. Here we go. There we go. Found it.
by Noah
Found
Pert.
it. Hold on. Where's the chat?
What?
Here you go. I
Oh,
guess I
nice.
can also put it. So this is the LVM.
Oh, like
Emacs,
official.
what I can tell.
Oh, very cool.
Yeah, there we go. LVM mode. Oh, yeah, there we go.
Okay,
Because
I'm
I
gonna just
knew they
steal
had one
this
for
then.
MLIR, so I thought they probably also have one for LVMIR.
What happened? It got confused pasting the URL.
For the Jesus, yeah, you should probably use quotes for stuff like that generally.
Yes.
You can also do it for curl. I would do curl -L and then curl-LO, L capital O, capital L capital O instead of redirecting.
Like
Because
this?
that will save it to the So curl. What this does is capital L
Interesting.
follows redirects, so that means follow location, and don't put the file name after it though, because I wasn't done explaining. You hit enter before I was done explaining. Don't. What dash capital O does? It means use whatever file name it wants you to use.
Ah.
So curl dash capital LO is typically what you want to do for curl. It's not wget. If you're using wget, just put in the URL. For curl, you typically want to do a bit more. Because also, if this thing redirects you and you just put curl there, it will just hand you the HTTP redirect. It will not try to follow that automatically unless you tell it to. So now you have an Emacs mode for LVM, for LVMIR. And I'm pretty sure there's also like a Vim mode for the people that are into that.
It doesn't work.
Somewhere.
What happened?
Broke.
It
What did you-
downloaded.
You
for
downloaded
fuck's
the
sake. I didn't get
website.
the raw.
You
I
didn't get
clicked the wrong
link.
link.
I gave you
Classic.
the wrong link, probably. My bad. So this is the
That's
actual
me.
the raw link.
There we go. There we go. There
That's a
we go.
classic. You try to download something from Git and you get the goddamn website.
I was like, why is there a doc type?
Oh,
Hey.
you might have to switch to LVM. There we go. That's better. Oh, I was looking at the wrong screen again. This is so confusing. Hold on. I'm gonna scream in the background for now. Oh, I guess I'll put it on this monitor. That way I won't.
Oh,
So
Uchinara Konoha says, in terms of machine instructions, how does that change? That's probably the discardable thing we were talking about. It doesn't. It actually just changes the semantics of the language so that it doesn't create a type error or a semantic error during type checking. Okay, what are we looking at, Sarade? I've not. delve
Okay,
this deep.
so I'm going to explain this. In LLVM, if it starts, so LLVM uses sigils for a lot of things, and the reason is anything that doesn't have a sigil is a built-in thing, either like an attribute or a type or a keyword most of the time, or like an instruction. That way it's easy to add things because they're not going to conflict with anything. So if it starts with an @, it's a global value, either a variable or a function. So functions always start with an @. In this case, it's a variable, the first thing, the cond. And we see it's private, which means it's internal to the module. It won't be exported. It won't be in the symbol table. So for modules, we'll have to conditionally add that. And then a global means it's a global variable. The alternative would be constant, if I recall correctly, to make this a constant. And then the I64 is the type, and in this case, 10 is the initial value, and it has an alignment of 8. Yeah, what's important is that you specify the alignment because global variables by default are aligned to 1, and that will crash if you don't align them properly. Not necessarily that it will crash, but the optimizer is going to be very unhappy with this because that's UB, and it will just throw away code like crazy if you don't align it. So it works in debug mode, but it crashes horribly when you optimize it if you don't put the alignment there. But that's only for globals. If you do an alloca locally, those are aligned properly by default. So that's just for globals.
That's
so. Then we have define. Define is how you define a function. If you scroll a bit down, the alternative is declare. That declares an external function or built-in, because you have to declare built-ins. No unwind because we don't have exceptions. That tells it do not generate any unwind tables.
Jesus.
Now, this is familiar. This is basically like the C function syntax. It returns an I64 and takes some parameters. In LLVM, there are, since version 15, there are no longer type pointers. It's just opaque pointers. That may seem weird if you're not used to it, but it actually makes things a lot easier. It's because before that, you had to insert a bunch of pointless bit casts and optimization passes. A lot of them don't really care too much about what type a pointer is. They only care where a pointer came from, and that's independent of the type. So this is basically a simplification that helps everyone. And the thing is, you might say, oh, but having no type information with pointers sounds like a horrible idea. No, because we've already done type checking when we get to emitting. We know that the program is valid. We just need to emit it now. And if you know that the program is valid, then you don't need, then opaque pointers are fine. And furthermore, in our internal representation, we do have the types. So that's not an issue. The fact that LLVM only has the pointer actually makes this easier. So opaque pointers, good, but this also means that you need at least LLVM 15 to be able to compile this, because before that it wouldn't recognize the syntax.
To expand on that,
to support type pointers. Sorry, what did you say?
To expand on that, it's kind of confusing. Like, why? What do you mean pointers don't have types? Because if you dereference a void pointer, that doesn't work.
Exactly. That's why you see the load has a type.
Exactly. So what now happens is every time you dereference it, the dereference actually specifies what type it'd like to dereference the pointer as. So this wants to dereference the pointer of condition as an I64.
Yeah.
So imagine in C, if you wrote like, oh, I'm casting this to uint32 t pointer, then dereferencing that, and then
basically
you get condition.
That, which is what you have to do, for instance, if you try to dereference something in GDB, because GDB doesn't know what the type is.
Then we can just do load I32 pointer cond, and if we reference it regularly, then we can just do load I64 pointer cond, right?
And this makes it very easy to do type punning. It also means that type punning is very much not UB in LLVM, so you can just store a double and load as an I64, though you should really be using, FP to int for that. But what it is useful for is copying structs, because LLVM doesn't allow casting structs. So the way you cast a struct is you create a local variable of the right size, you copy it into that and load it back out as the other type, and the optimizer will get rid of that. But that's the only way to cast between structs, to do like a bit cast between structs.
Bit messy.
Yeah, apart from that, we have basic blocks. This will be used, like we've talked about this before on stream, pretty sure. So these have, this is interesting because LLVM, the way temporary names work on LLVM, temporary values, and that includes basic blocks and values, start with a % sign. by default, if you don't give them a name, they're numbered. But they have to be numbered correctly if they're numbered. If I just omit 3, that's not valid IR. And that's a good thing, because that is a check. That's an additional check to make sure, okay, everything that has a value, am I assigning it to something? So that's another sanity check here. If we mess up and forget to assign something a value, then under the hood, it will internally still get a value, and suddenly the numbers won't match up anymore, and it will complain. So you could get around this error by just calling everything V1, V2, V3, but we want this error. That's a good thing. It is annoying to deal with if you're not familiar with it, but if you are, then it's a good thing to have it. But we don't want to deal with that with basic blocks, because it will also typically count basic blocks. So what happens if you omit that BB0 label, then that basic block gets the number 3. And the next instruction would have to have the number 4. And that is confusing. So for basic blocks, we don't want that, so we give them a name. But for values, that's a good thing.
Very cool. And then it's basically like, so the internal instruction syntax, it seems to be sort of like a function call without parentheses.
Well, it's just like an assembly instruction.
Well, it returns a value. That's the confusing part.
It returns value. Yeah, it's basically like the IR syntax for intercept, because that one is modeled after this one.
Yes. So it's like this is the name for the result of this expression.
Yes. And you can see some things like the store simply don't have a result. And if you try to assign the result of that to something, it doesn't work. And crucially, the same is true for calls that return void. If you try to assign that to something, that doesn't work either.
So when we call, why are we specifying I32?
That's the return value. You have to always put... LVM is very verbose when it comes to types. You
So we
can't
have to repeat
overload
it?
or anything, so I don't think there's a reason for that. But you have to specify the type here.
That's stupid.
The only things that can be overloaded sort of are built-ins, sort of, where there the type matters. But because built-ins are implemented via functions that you can just declare and call. So that might be because of that. But the thing is, LVMIR simply is rather verbose when it comes to types. For instance, you can see we have to write I64-8. It knows that 8 is an I64. We still have to write it. That's just how it is.
So it kind of doesn't do any niceties or quality of life when it comes
It
to...
depends.
There's no
Something-
fancy sugar. The
No,
syntax
exactly.
is always type value,
Yeah.
so you always have to type value, even
Yeah.
if it was implicit.
Nice.
Even in cases like if you look at the definition of 8, you might think, okay, add I64, 48, and 7. Okay, maybe there's some sugar there, but that's not actually syntactic sugar, because an add you can only add 2 operands of the same type. So they
They're
have to
already
be
both
the same type,
I64.
both of them. So that's why you only have to write the type once, because you can only specify the type once. Because both have to be the same type, have to have the same type. Otherwise, it will complain. Like you can
yeah.
add an
yeah.
I32 now to an I64, you have to sign extended first, or zero extend, whatever is more appropriate. And can we see some control flow in there? Oh yeah, I think.
Yes,
we
so
can. So that's interesting. This I compare not equal is basically how we quote unquote convert the condition to a bool, and the bool in LVM is an I1, because you can only branch on an I1.
naturally.
So by checking, is this number not equal to 0, that's one way to convert it to a bool.
Exactly. Just like we would do in assembly. In the assembly backend, we have like the jump 0.
Yeah, something like that.
So we basically say if it's 0, branch this way, otherwise go to L2. And that's exactly what this says, right?
Yes, if it's
not equal to 0, go to
equal to 0, meaning if it's true, that's just the I compare not 0 is just a cast to bool. That's the way to think about it. Or conversion.
Okay, yeah.
So if that the condition is true, we branch to BB2, or otherwise to BB3, which duh. This doesn't even use a phi because we store to a variable.
That's right. And there's a question in chat. This is the code format you have to give LLVM to compile to different machines. So you do your code, this assembly lookalike thing to compiled.
That is one backend, yes.
So yeah, maybe a good thing to open up would be the compilation overview document. because just on this first page here, there's a wonderful little diagram. I think that would be great. So this right here is like the compiler. And basically, there's a lot of internals, but imagine if you ignore the box, it's just source code to target code, right? And target code may be anything. Currently, we have a few different backends, which you can see if you do -ts or -ts or --targets. And so you can see we have an assembly backend. We have an Intel syntax assembly. We now have LLVM-IR. We have an object file backend, which is either ELF or COF object files with assembled x86-64 machine code in there. So we have all sorts of backends where we can create object files with machine code, or we can create assembly. And now, thanks to Sarade, we can now generate LLVM.
Mm-hmm.
Can't you like
So perhaps
call
an
a
interesting thing.
particular or what?
Oh, sorry. You go
Well,
first.
okay, sure. From my usage of LLVM, you're able to like call particular API calls to actually make LLVM generate the object file after it generates the LLVM IR. Is that your plan, or are you just going to stick to your own object generation code?
I'm not planning to do that because that's for two reasons. Like, I use LLVM as a library personally, but generally that can be a bit finicky sometimes, especially debugging it is not easy unless you have a build of it that enables assertions and dump, and you need to build that manually. I don't think it has builds for that officially, so you have to build LLVM yourself to be able to debug it properly, and that's not that easy. Like, I have a pretty good CPU with 32 threads, and it takes me 20 minutes to compile it.
I see.
So
Okay,
if you only have a laptop, forget about it. It will probably take hours to compile, so that is unfeasible. That's one reason also Lens doesn't want to depend on LV and the library, I think, or whatever your reason was exactly. But I recall you not wanting to do that.
That's definitely a big one.
So because of that, we're only going to emit LVMIR and only in text form. There is a bitcode format that is equivalent, but that would be a lot harder to emit and debug, so I'm not dealing with that manually. But yes, if you use LVM as a library, you can use it to generate IR in memory and then directly optimize it, compile it, emit an object file or assembly without having to write it out in text form. You can do that with LLVM. We're not planning on doing that.
Interesting.
Well, if we do that, it would just add so much code complexity, because that would all have to be behind an if-def. Because like some people don't even have Clang, and Clang doesn't run on every system that Intercept can compile on. So why would we limit ourselves to only one ecosystem of like, we'll just support whatever Clang supports? It's like, I want to support what Clang supports and what GCC supports and what, like, I want to do everything possible. I want it to run in as many places.
What you're trying to do. Like, if you want to use LLVM as your main backend, then absolutely use liblllvm.
Yes,
Like,
yes.
once you're somewhat familiar with how it works, I would recommend maybe if you're just starting out, you can try emitting it manually, because that might be easy to debug if you're not perfectly familiar with how it works. Because debugging LLVM is a bit more nuanced than just debugging a regular library, because it's so big you can't build it, and it's hard to build it in debug mode, and running it in debug mode isn't feasible because the program takes a minute to start, because LLVM compiled in debug mode is a 2 GB library with just debug symbols all over the place. So you can't debug it like you normally would, because it's just too goddamn slow. So you have to kind of work around it and debug it in release mode with assertions enable and some other stuff. And that works if you know what you're doing, more or less. If you completely new to LLVM, that can be very confusing. And also, there isn't really that good of a documentation for how to exactly use everything. You kind of have to figure that out. There is documentation, but it mostly helps if you're already familiar with it.
Right.
Right.
Interesting. I've never actually seen that take on using just like generating the text format just manually. Interesting.
But yeah, if you don't want to depend on the library, that's the easiest way of doing it, probably, because a lot more systems are going to run Clang than have the LLVM headers and static libraries, or shared library even. Shared library, yes, but not the like headers and everything that you need.
Cool.
Exactly. All right, maybe let's think about what this program actually does.
Oh yeah, but before that, King Bones has a very interesting question in chat that you need to answer.
When does karaoke night start?
That's a good question. Len's Discord karaoke nights.
Oh god,
What?
I can't think so without me.
I don't even know how that would work. What is that?
We can find a karaoke service and we can voice chat karaoke. It'll be great.
But the timing.
Good God.
I mean,
Oh,
you only
my
have to.
God.
There's got to be like an online karaoke where you can web browser it and you're just not
No,
like
but
listening
even
to other
then
people.
sound out of sync because either we'd be out of sync because we'd have to either start offset from one another, or even if we start at the same time relative to some fixed point somewhere, we'd still be out of sync in VC. So either
Well, I'm researching it right now. I'm gonna don't overthink it. I'm gonna find some answers.
okay, you
Like
do
it.
you. We'll get back to LVM for the time being. So you wanted to do what this does. You can run it. I'm not sure what you have in your system. Do you have LLI? Yeah, that's the L not found. Interesting. Do you you have Clang, but not? Do you have LLC?
Nope.
Do you have opt?
No.
Interesting.
You have to
Because
your
you might not have. How did you install Clang? I think you installed only Clang. That might be it.
That would be annoying.
Because
I mean,
LLVM bin. Is there anything else in LLVM bin?
there's a few things.
There's LLD. Okay, you appear to not have most of the Clang tools though, or most of the LVM tools because you don't have LLC, you don't have LLI, you don't have op. You could try getting a release that has those, but it's not that important. We can do most of the stuff with Clang. So what you can do is just compile it with Clang and then run it, for instance, because LLI would be the LVM interpreter that will let you just run it without compiling it to a file. So yeah, and you can just run that. That warning, ignore that. That's just, yeah. We're not specifying a target REPL because Clang knows that better than us.
Exactly, yep. Like how would I...
You can disable. Like the way I'd even do it is if we call Clang from the intercept compiler, if we end up implementing that, I just disable that warning.
Yeah.
On the line because it doesn't. This warning has been there for years, as I recall, and it's not a problem. I think they were talking about deprecating it eventually, but not sure if they were going to do that. But there you go.
PogChamp.
Works, and what you can do now too is that would be interesting is optimize it and print out IR again.
Hold on. A little bit of an interesting thing. It's printing a new line.
Yeah, that's expected if you look at the code.
Is that what it's meant to do?
I think so. Is it?
I don't think so.
Look, that's what it's doing. It calls put down a number and then it prints a new line.
So we should start with 10. We print. So what I'm saying is we have an empty line. It's printing a literal 10.
Maybe? Is that just your terminal, maybe?
I don't think so. I can...
50.
Here. Okay, it is.
Well,
it's expected. There you go.
Can you type like ls or something? Yeah.
It is just happening. Why is that happening?
It is just your shell. No, not just your terminal. I think it's just your shell. I think new shell just does that apparently.
It shouldn't.
It would seem that new shell, or maybe your terminal is scuffed. I have no idea.
It might be my prompt.
It is not my LVM backend. That's the only thing I want to say.
Yes, you are correct.
Because I can tell from looking at the IR that it works. Like the IR looks correct.
All right, the best I've got for a karaoke solution, because nobody seems to have a ready-made solution that isn't like going to be expensive, is just whoever's singing is also screen sharing, and that's it.
God. That's still gonna end up having a delay, I think, but okay.
Depends on your hardware and your audio, but it shouldn't be bad. It's a lot better than actual internet delay. We can test it out.
Either way, it doesn't particularly matter to me because I can't sing anyway. So
Neither can I, but that's the best part. That's what karaoke's for.
I don't like singing either. At least not
Mm.
with other people. So um,
What about with other people on a recorded live stream so we can go back and watch it again?
I wonder. Now, what we can try is optimizing this. So for that, just run it through Clang, but do -s -emit LLVM.
Duet.
Okay, so
-S.
don't hit enter before I say -S. I should have specified that. And give it some other file name that not while.ll, otherwise it will just not work probably.
Well, I
Or
have to
might
give it.
work.
You're saying like put an output file name like -o.
File like .op. Like while.op.ll or whatever. That's what I typically do, and that should work. And you have to do -03 obviously, otherwise it's not going to optimize.
Oh, okay, okay.
Normally I do this with op, but I think Clang should also be able to do that. But let's see if it does that. There we go. That's better.
Well, you have a phi node.
This, yeah, we now have a phi node, so that it's still using the global because it could have side effects. Yeah, so this is a bit of an annoying thing, but it should. That's also interesting that it's still using the global, even though there's nothing else in here. But I think this is also maybe not that interesting of a case to optimize because it actually has to do I/O. And if you try something that just does computations, then you'll end up seeing some great. You could try the Rule 110. Try Rule 110.
Is that a test or an example? That's an example.
I don't remember. Yeah. We can try. Let's look at the LVMIR first, maybe, just because that's a bit more interesting.
It's looking pretty good.
Mhm.
This looks like a loop where
So
we call two
the local
functions.
variable plus the lockers. That's why I call it a locker, and it's also called a locker in C. So
Locker.
oh, and we have some. You can see some weirdness already that I've had to deal with because of how IR works. On line 40, we're emitting something that has a bit of a different name, and that's because sometimes I need to emit multiple LLVM instructions for one IR instruction, for one intercept IR instruction, and then I just use a temporary name that is something dot the number of the instruction to make sure it's identical. And what this is. This is some sort of comparison because a comparison always returns an I1, but in intercept it's an I64. So we extend it to an I64 because of that. So the actual result of the 5 is an I64 because we don't have bool currently in intercept. So we need to 0 extend it. And by the way, never try to sign extend an I1. I learned that.
Yeah, that'll go well.
Yeah.
Don't sign extend an I1.
I wonder what the sign
Zero
is.
extended, always.
Uchinara Konohas have to go. Have a good day. Bye, Uchinara. Thank you for coming. Thank you for tuning in. We'll see you
The
again.
problem is if you sign extend an I1, you get -1. And then if you add those, weird things happen.
Yep.
You still suddenly get negative numbers. But yeah. So that's the optimized file. And if we have some more interesting things, I think if you scroll down, maybe.
Okay.
I think there was a phi, I think, somewhere. There we go, there's a phi.
A phi in the wild.
Phi.
Some if else's.
Mhm.
Are you 0 extending every single I1?
Sorry, what?
Are you 0 extending every single I1?
Apparently only if it's the not used by a branch. Which I'm not sure how I'm doing that exactly. I need to check. Hold on. I'm curious.
That feels like that should get optimized.
No, by default, I am just emitting it as like 0 extended apparently. But I think this might have to do with how we represent it internally. Maybe like with how the branches are handled internally. I'm not sure.
Neat.
Branch conditional. Yeah, we emit the branch condition, but well, I'm not sure exactly why that. Oh, I see. No. That is no. I know what's going on there now. So what's going on there is whenever we have a comparison in intercept, I am zero extending it, but this isn't a comparison in intercept, but we're probably just using an integer as a condition or some variable. So that comparison is actually a cast to bool, basically.
Oh, I see. Okay.
Comparisons are always zero extended. That's just so we get an I1. So that's converting it to an I1. Because what the actual branch condition is the 5, which is, yeah, see, this is horrible here. We're comparing,
It's a truncate.
we're sign extending to I64, and then
Yeah.
we are truncate, we are casting back to bool.
Yeah.
So that nonsense will go away once we have actual bools.
Okay, I see.
But right now we're comparing zero extending, and then we're truncating back to I1 effectively. So yeah, there's some weirdness in this simply because LLVM IR has slightly different semantics from RIR. In this case, and also in another, what was the other case? There's some other. I think it's mostly pointer arithmetic because in LLVM you can't add pointers. You can only add integers. For computing indices and such, you actually use the get element pointer instruction in LLVM IR. But the problem is that the Cogent frontend currently converts array access and member accesses into a series of multipliers and adds before we ever get to emitting LLVM IR.
Yeah.
So to actually be able to use get element pointer instructions, well, what I'm currently doing is I am trying to, if it ends up being a multiple of the element size, I convert it to a get element pointer, like I convert it back. But the default is just to convert the pointers to integers, add them as integers, and convert the result back to a pointer. And by convert, I mean that's just like a nominal conversion. There's a pointer to into pointer instruction that does that. That is relevant on some systems where an integer, where pointers may have different sizes and such. It's just gonna end up being a no-op in here. So it's just to satisfy the type system basically, because you can't add pointers.
Interesting.
Or rather, you can't add a pointer to an integer or subtract point. Subtract pointers, I'm not sure. I don't think you can do that either, but you can't add a pointer to an integer in LLVM IR. I see written some IR.
We've got a good question in chat. Phi node. What's a phi node?
I hardly know her.
Oh my god.
Okay, so
Every time I hear an explanation for a phi node, I'm like, that's stuck. I'm finally going to remember what phis do, and the next day it's gone again.
they're definitely elusive, but they're not too bad, Niall. Here's my explanation for you. Hopefully you can understand this basic program. So we have like basic blocks, and we have instructions within each basic block. And we're not going to get too far into it, but basically we want to declare a variable called x, and then we want to say, based on some input condition, to assign x to either 69 or 42, and then we want to return x from like the whole program, right? So like in C, this might look like int x, if input condition, then x equals 69, else x equals 42, right? And it would look something like that, return x. And what you could do is basically have, and again, in this scenario, this could be a local, right? Where, where we could just declare memory, okay, we need some stack space. And then when we assign x to 69, we just move 69 into that memory. Or if we assign 42, we just load it into that memory. And then when we return it, then we have to load it from the memory again, right? To get whatever value that may have been assigned to it previously, based on if the control flow went to BB1 or BB2. So we kind of have a diamond happening. Let me try and draw this really quick. We kind of have a diamond happening where we can branch to BB2 and BB1, which just stands for basic block, by the way. We have this thing going on, right? Basic block 0 can go to either BB1 or BB2, and then both of those just go to BB3. But the problem is that BB3 needs a value that may come from either BB2 or BB1. And to do that, like we said, we could just load and store from memory, because it's memory, it'll be there, we can remember things through it, that's easy. The problem is that's not efficient or optimized in any way, and it doesn't allow for optimizations because storing to a variable may have side effects later that we can't get rid of, if that makes sense. But if we know that this value, it's declared here, it's used for the last time here, and then in between is just assignments to it, it's like, oh, this can actually all go in one register, right? And as a human writing assembly, you would put it all in one register. You'd say, oh, X is like in the RBX register, and you either move 69 into RBX or 42 into RBX, and then you just return RBX, right?
Register allocator thing.
Uh,
We're looking.
Yeah,
Well, actually,
it's
it
not
has more to
fully.
say, right?
So yeah, SSA only exists in order for optimizations to occur surrounding
Well,
this register allocation. But
yeah.
But you're right. It's an SSA invariant that we need to hold up, where this X and this X essentially become X1 and
Right.
X2. And then what
Yeah.
X do we load here? Is it X1 or X2? We don't know.
Mhm.
So to solve that, then we have to say, oh, return phi. And then phi becomes this thing where it's like, well, if we're coming from BB1, then please like give me X1. But if we're coming from BB2, then give me X2. So then when we return the phi, we can either load this one or this one. And at this point, it allows us to not, like the memory load and store has kind of been abstracted away so that it's not necessary anymore. If that makes sense. Because if you just hard-coded like load and stores, it does also work.
Mm-hmm.
That's always what I did, is I didn't want to wrap my head around what made a phi useful. I always knew what a phi did, but they never felt useful to me. And like one stream, you guys were talking about the register allocator, or it was in the text or something, and all of the problems with allocating registers and like doing this lifetime check and whatnot made phis seem a lot more useful. And that's the part I never remember.
I mean, the only
Funny
reason it actually
enough,
exists is because of SSA,
Oh.
right? Like single static assignment.
Hold on, I need to turn you up locally. Oh, you're already on 200%. I can't turn you up any further.
Oh, really? Okay, hold on. Is this better?
No.
No. Crap. Well, okay. So basically, like, from my understanding, yeah, you're definitely right about the load and store thing. Like, technically speaking, you could just use memory. But if you want to get things into registers, but the IR itself is using SSA, so each assignment to a variable or each assignment to a register can only ever have, there can only ever be one of them. Then you need phi nodes in order to get the right data flow for those register usages, basically.
Exactly.
Like the way to do it.
The thing about phi nodes is that they're really a way of encoding values using control flow, and they're less relevant in the array actually, because you need to do all sorts of things in register allocation anyway. And typically there is a step called SSA destruction that happens before even instruction selection that lowers all phis to a series of copies and exchange instructions.
Exactly.
Yeah.
Because phis are they are mostly an optimization, but certain control flow dependent data flow is often easier to encode with phis. Like, especially if you have things like you don't need to explicitly create a loop variable and assign to it and load from it, because if it's already compiler generated, you might as well use a phi for that. And it's just easier to deal with them in that regard. So you need phis eventually for optimizations if you want to write in a performant compiler, but you could leave all of that to some sort. Like if you're emitting LLVM-IR, you technically don't need to emit phis because LLVM will just convert. It has a something called mem to reg pass, which converts memory accesses to phi nodes as best it can. But I found that phi nodes, once you are familiar with them and you know what they do, they are often even or more straightforward to use than just declaring a variable. Especially because you may have already emitted some IR and you did, where do you put the declaration? And it's annoying to have to deal with all of that. So
if anyone's still struggling, another way to think about it might be that the phi node just gives a single name in the SSA like a single value, to multiple other SSA values.
Yeah, the general definition is a phi node selects between values depending on control flow.
Yeah. It's kind of just like naming these different things phi once we get to this point in the control flow.
It's hard to explain phi nodes well without explaining SSA and everything around it. It's
Exactly.
not something that makes too much sense in a vacuum, so it can definitely be confusing.
Thanks for the explanations. As a non-low-level programmer, I understood something like 40% of the context. That's perfect. I also
Why I
don't know
like
what
doing
SSA
low-level
is.
work.
Oh dear.
A single static assignment.
Static single assignment.
Oh well,
Yeah, I know there are both forms. I have always known the single static assignment.
Dang, I say the other one.
But I think the SSA book also uses static single assignment, so both of them are reasonably common.
Yeah.
What's the
And then the
SSA book
evidence-
called again? How do I find it?
The SSA book, just search for SSA book.
Lots
They
of
use,
authors. That's what it is.
They use static single assignment. I use single static assignment.
Static single assignment.
This is a whole. It's very complicated. Like, don't.
If you're new to compiler development, this is not what you want to read. This is very complicated stuff. This is like starting with Calc 2 when you're trying to learn how to solve linear equations. Don't do that.
Exactly. Don't start with this. But this is like to get your toes dipped in the pool. Like this, you can see what it's like. Like there's a lot of stuff going on. There's a lot of
But
stuff
you-
to learn.
That gets rather complicated really quickly with all of with dominated trees and construction and destruction algorithms and all of that, which is all very useful. But if you're new to even new to SSAs, I'm not sure the SSA book is the best introduction.
Right. I think honestly there isn't any good introduction because it kind of sucks no matter what. It's confusing.
That's the thing about topics in compiler development. Either you just don't know about it, or the people that do know about it, they just know about it and they don't think about writing about it. And if they do, they write about it in such a way that only other people who already know about it are going to understand it a lot of the time. That's often the problem with compiler resources.
And there is quite a bit on SSA in the compiler docs, I'm pretty sure. So if you are interested enough to go through PDFs of things, then I think the developer's PDF would have things that you're looking for as far as when it comes to the IR stuff.
I think that would be the case, yeah. I'm
And-
not sure how up to date it is, but
It's
we
not.
have some in this somewhere.
It's up to date as in not up to date, but it
I've
is
already
fine.
submitted- yeah, I still need to submit a PR to fix the indentation everywhere.
Yes, I've butchered this document.
It's not necessarily that. It's also just that I'm just very used to typesetting, and I'm very particular when it comes to about typesetting. Like if something is typesetting correctly, it just sticks out like a sore thumb.
Like all these indents at the start of. Oh, there's not one there.
For instance, if you have an
where was I?
indentation after something that is not a paragraph.
See, none of those are indented, but then there's like diagrams with indentation after them, like right there.
Yeah,
Yeah,
this.
that's what it.
Yeah, and as soon as you mentioned that to me, I was like, oh yeah, that doesn't make sense, and now I see it
Yeah.
everywhere.
Because for people that are confused about that, indentation is a paragraph separator, not a paragraph terminator or initial or whatever.
It's not a required for the start.
Yeah,
That's correct. Yeah.
Indentation separates paragraphs, which is why in documents where empty lines are used to separate paragraphs, we don't use indentation because both would be useless. Both together, that doesn't make sense. It's either one or the other.
That makes
Most
sense.
typeset books use indentation simply because that conserves space. It conserves, like good typesetting conserves a lot of space. I've typeset a book before for Agma. It was actually his, I think, bachelor's thesis or something. It's his book about Arjun. His version was 220 pages. When I typeset it, the result was like 140 pages, and we added content.
Oh my god.
That's
so,
perfect.
Yeah, good typesetting can conserve a lot of space, which is good because you don't want to. It's one, because you don't want to waste paper. It's expensive, and also because it becomes very tiresome to read. Like if you have to constantly go from page to page, that's just not particularly nice. It's also just not nice to look at. Not nice to look at. Like, it looks very unprofessional if you just have a bunch of text that's not even justified and with like double, with 2 lines, with like 2 empty lines between them. Like, what's it called? The lines, double line spacing or whatever it's called.
I hate. Oh my god, yeah, doubles.
Yeah, especially some people, for some ungodly reason, say that you should use 1.5, which is incorrect. What you should be using is 1.2, which, if you're doing 12 point, is 14.4 points.
Specifically 1.2. I never heard that before.
Yeah.
It's 1.2, yes.
Wow.
You're making me want to go
One is-
actually set up a bunch of defaults for LibreOffice, so I
Well,
can just still have a
just use
decent.
LaTeX. It has the defaults. Oh yeah, this is the also lens is
Use
just
what?
doing.
Oh my
So go back to the unoptimized version so we can put them side by side. Otherwise, no one's going to know. So
Oh
this is rule 110. Looks pretty normal. Nothing too out of the ordinary. And then we have the optimized version, and you'll see that it looks a bit different. We have some loop unroll happening here.
Oh my gosh.
It's unroll your thing.
Nice.
That's a 5. Look at that.
That's a 5 never seen before.
Oh my god. Is that that's a 5 from every single oh my
From
god.
a lot of things, yes.
There's 16 of them.
Holy crap.
It's actually funny. If you had opt, you could run opt, and opt generates something slightly differently. It also it vectorizes it, but it kind of, this also unrolls the vector. Opt keeps it in a vector.
Oh.
So
When
incredible.
I mentioned LibreOffice, you mentioned something else, but I didn't hear what it was.
I was going to say just use LaTeX. It has all of the defaults. Most of the
Yeah.
defaults. Some of the defaults are insane,
Yeah,
but like
need
most
to
of
at
the
some point.
basic defaults are fairly sane. Most of them. What is
I need-
insane is the formatting of headings, because it's all caps and italic. That is moronic.
Yeah, for now I like my GUI editor. I still need to learn tech, but I haven't done that yet.
You like a WYSIWYG?
My I write a lot of code, so I don't need a WYSIWYG. A lot of things I would prefer to be just plain text. But for right now, my brain really likes seeing results, and WYSIWYG is fast.
I
I
see.
found LaTeX to be faster to type say what I want, but I also
agree.
have 15 years of experience in it, so
Yeah. Oh no, I'm almost I'm 99.9% sure that I will have a better time in tech. But I'm not trying to do anything serious right now. I'm just splurging ideas onto a paper. So if the defaults for my WYSIWYG are better, then I'll have a better looking brain blast onto paper, and I can formalize it later in something else.
I see.
I'm sorry.
I don't think I ever really use any WYSIWYG editors for anything anymore.
I
Except-
rarely do as well.
Except if someone else is like sending me something to proofread, then
Mhm.
they used something like Word or something. Then
Yeah,
sure,
I have to
otherwise
read
not.
legal documents with like LibreOffice.
Oh god, don't they have PDFs?
Well, I request PDFs as often as possible, but everybody just sends fucking DocX in America. It's cancer.
It's bad. Yeah. To be fair, I save almost everything I do as DocX. If I have to send
No.
it to a client, I try to make it a PDF, but I also have an irrational fear of PDFs. So
That's not
I
irrational.
I don't use PDFs if I don't have to, but sending things to clients is usually a have to.
I
Yep.
use PDF for everything. I need to send it to someone.
I do too. I go with the flow.
Yeah, if I'm sending a non-editable document, it's a PDF or
Also,
a plain text file.
just got to shout out Burmo, AlexDev, XWidget, FunkDev, and Pablo Pepe 69.
Pablo Pepe.
Yeah, 69.
Oh.
Thank you so much for the follows.
One more thing that I wanted to point out, because we'll have to change that eventually, or I'll have to. If we look on the left side there,
This one.
you'll see the second function is defined private. So currently all functions except for main are internal. And that means that's basically like a static function in C, but
Yeah.
even more internal. Like, it doesn't even get a name in the symbol template or anything. And that means it can just inline it and delete it if it doesn't use it anymore. So it's unused, it will just delete it. As you can see here, it's probably gone.
Yeah,
Okay.
it's unrolled it,
Mhm.
which is incredible that it's just hard-coded Rule 110 results.
Yeah. Wow.
It's pretty pog.
hmm
And then just tail call after tail call.
Yeah,
It-
LLVM's definition of tail call is a bit interesting. It's
Yeah.
not exactly a tail call. But the thing is also that tail call is not mandatory if you just write tail call. So that can just be it saying, okay, try a tail call here, maybe. Because there's another one that says must tail. That one, if it can't lower it to a tail call, it will error, and that's intended for things like scheme where tail calls are required by the spec.
Naturally.
So that's what must tail is for. But just tail call is just a hint, more or less, as I understand it. We have a switch because LLVM has that too.
That's pretty pog.
That's like a jump table. Like
Yep.
switch
So we have
was
so my chain of if else statements.
yeah, it realized what was going on.
So here, if we go to the actual original intercept, this chain of if else statements within the loop is what it figured out.
Probably. That's probably what it is.
Yep, because this is 0 through 0, 1, 2, 3, 4, 5, 6. And then it's probably a fall through otherwise.
No, the default is the first labeled on first line.
This one.
That's the default. No, that's the condition, the one after that.
This one.
Yeah, that's the default. Yes.
So that's
16.
the else.
Could be, yeah. I'm not actually sure what it's that it might very yeah. I think that's what it's doing here, but who knows what the optimizer like managed to figure out here.
Right. But yeah, so it made some sort of jump table out of this big if else tree. And then it used a phi to merge the values.
I know, you can see where it inlined is. Oh god, the label names are brilliant. Yeah.
So yeah, we then branch to calculate state exit, which branches to %.not.
No, that's the condition.
Oh, fuck.
First thing is the branch condition.
It branches to
label is a block.
Okay, so it either goes to BB3 or BB2. So if we go to
BB2, back to the top.
Yep, that's just back to the unrolled loop.
So yeah,
Beautiful.
I was
and you
gonna.
can see in the unrolled loop, select is basically like a ternary expression. That's a way to do branching without branching. That's probably going to become a conditional move if it's clever. And that just because it calls putcha on the result of that, it's probably selecting between a star and a space here,
Right.
which is brilliant. So yeah, it's doing a lot of work here, the optimizer, and we obviously, perhaps unsurprising, would be the result of something like the conditions test. You can compile that and optimize it, and I think the result of that is pretty obvious.
Yeah.
I was gonna go look up some basic tutorials for LaTeX.
Oh
but
no.
I just started with the word LaTeX. I
I
don't use, I don't clear my anyway. Glad I'm not streaming.
That's a common problem when I'm looking up stuff for LaTeX. It gives me the wrong LaTeX.
Well, I mean, like, I haven't even hit search yet. This is just in my recent history.
How to wrap tight box in LaTeX.
Elf Girl.
Oh god. It doesn't help that we have terminology such as boxes and glue in LaTeX.
Yeah.
Anyway.
Glue.
Yeah, you can try compiling the comparison test, for instance, because that has a lot of operations.
That's a good idea. We have some chat. Zara says, wait, we optimize in this channel? People leave. You can upload it on Google Drive, Mr. Streamer. It's sad how common that is. Oh, Pablo Pepe 69 says, hey, he talks. He speaks. Isidiush says, hi, Lens. What's that language on the right side? This is LLVM IR. This is optimized LLVM IR generated from LLVM IR that was generated by our compiler Intercept.
Scroll up. This is why we don't specify the target triple, because it's this madness. And the thing above that is the target data layer. That looks like nonsense, but it makes sense. Trust me. That's just telling you what the size of a pointer is and such.
Oh yeah, naturally. Yeah, E-M colon W
Yeah,
dash
E is
P270 is clearly
Mhm.
saying that a pointer is 270 degrees of the log E, the natural log of minus, M, the mass of this file in electrons on disk.
So what
It's so clear.
What this means in particular is the little e is little endian, then dash m is the module format. In this case, W for Windows, E would be ELF. P270 is pointers in address space 270. Those are 32 by 32, like 32-bit pointers, 32-bit aligned. That's a default thing. That's like weird address spaces, 270 and 271, and also 272. The default address space is 0. So those are just weird things that use something. Then the alignment of an I-64 is 64 bits. The alignment of a long double is 128 bits. I'm not sure what N8 is. Oh, I'm looking at it in my compiler. That's the native integer widths that are supported. So that's 8, 16, 32, and 64-bit. And then S128 is something else again. Oh, the natural stack alignment is 128 bits, apparently, is what that means. And then there's also ways of specifying alignments for vectors, for instance, and you can add more integer types or whatever if the platform actually supports it. So if you had 128-bit registers, you'd put that in there as well, and so on. So that's what this thing means. It just tells it how to code gen.
It does make sense now. You're like, I'm starting to be able to understand it, and I hate that I understand it because it looks like nonsense.
It does look like nonsense if you don't know what it means. Yeah, it's just the values are separated by dashes. That's the only thing you need to know.
Sorry, so he just explains it like that? What the fuck, man?
I've written one of these before, so yes. I've carefully designed one of these before, so yes, I know what it means mostly. And I'm also currently looking at the common definition of one in my compiler, so that also helps a bit.
Ooh, I made a LaTeX PDF. It gave me a bunch of temporary files I don't want.
Yeah.
Yeah,
There's a
that's how
command line
that
option
works.
for that.
It's out like a half a dozen temporary files. That's just how it works.
Well, now I got to set up a build to not do that.
Here, let me. I've done this before. I'm trying to find
Pretty
it for
sure
you.
there's some way to specify to put it somewhere else. Output directory.
There's an output directory, yeah.
And or aux directory.
Yeah, I just leave it in the normal directory and just add them to git ignore or something. I can't be bothered. Also,
I do the
if you
same,
invoke
yeah.
it manually, always add interaction non-stop mode because the interactive mode is useless unless you know what you're doing. Like
Yeah,
it's
just
useless.
spam X.
Full stop. The only time when you use it is if you want to look up definitions of things. Then you might want to use it, or just run random LaTeX commands. That's what it's good for. But typically, no.
So on an error in a LaTeX file, it will actually enter you into a REPL after showing you the error, basically.
Ew.
Yeah, asking you to fix it or what to do to fix it.
Yes.
Which is pointless because you'd have to do that every time manually. That's stupid. So we don't do that. We just let it fail, fix it, and so on.
That's right.
LaTeX is a bit old-fashioned in that regard. It has some very weird defaults in some places, but also somewhat sane defaults when it comes to typesetting, mostly. So with this thing, we can compile that to LVMIR.
Yes. What
Some other thing that oh yeah, there was a question whether we're using S expressions as an intermediate representation. We are not. We are just using a format. So that's the unoptimized. They are very straightforward, I'd say.
It's pretty simple, yeah. We load the global A. We compare it if it's equal to 1. We use 0 extend to convert it to a bool. And then we add that value to 3, right? Or this is 0 extending to convert the bool to an integer, sorry.
Mm-hmm.
And then we add those together because that's what we do right here. We test if it's equal to 1, and then we add it to the value of A. And then we assign that to A.
Apparently, I didn't even know we could do that, but apparently LVMIR can deal with you emitting comparisons between literals because the actual LVM library doesn't let you do that. It just folds those automatically and gives you back a constant. If you try to like emit an add of two constants, it won't let you. The IR builder will fold it and return the result back to you. But apparently the IR can deal with that too. Which is good because that way I mean, we should probably do that eventually anyway when we create things in like IR add should check if it can add them and do so and so on by default, because this trivial constant folding is just better if we don't have to deal with that in the back end, because right now you probably have a bunch of weird rules to resolve adds of immediates in the instruction selector.
I'm fine with that if we treat it as an optimization.
I would not even make it an optimization. I would just do that by default because there's no reason to not do that.
You're right that there's no reason. It's just like a random want that I have.
Then I'll say, well, there is. If you don't have a reason, then that's not good enough.
That's fair.
You need a reason, because the reason against it is the reason for doing it is it simplifies the backend.
Well, yeah.
And you can't
Here's the
argue about debugging because everyone is going to expect that immediates are going to be inline anyway, and no one's going to debug 4 plus 7 to find out it's suddenly 11 instead of 12.
So it's not a pragmatic reason. It's a philosophical one. I know you're gonna love this.
Yeah, a philosophical reason is not a reason to not.
So here's the thing: the compiler should be able to emit code for any given input program.
Sure.
But if we can't emit code for 2 plus 2 because it always just emits 4, that's stupid.
It's not stupid. 2 plus 2 is 4. Why would you ever want to compute that? Everyone knows it's 4.
Right, and by default, I'm okay with having it do the folding. But it's just like, I want it to, semantically, I want it to be able to the compiler should be able to represent that program like all the way through without modifying it, like through a major optimization.
I disagree, because if you write 2 plus 2 in pretty much any compiler that isn't ours, anyone will write that with the expectation that it will get inline. In fact,
I know
that's
that. Yeah.
The point where even if you write that in assembly, assemblers will inline that. Like, everyone expects that, well, if you write an expression that consists only of literal values, it will combine them into one, and that computation will never make it into the backend. That's the expectation that everyone has, and there's no reason to do it differently. It's just pointless overcomplication.
Well, so actually, there is another reason why you might want to do it, which is called just generally in like compiler lingo, it's called canonicalization or whatever that word is. You want to minimize the possible programs that your compiler can output, actually, because then your optimizer needs to deal with less patterns. Like for instance, if you're doing a for loop and a while loop with the exact same code gen, and you use the exact same pattern for both, and you don't have any sort of special case for one of them, then the optimizer only has to look for one pattern. And the same applies for literals. If everything, every single constant expression is reduced down to a literal, then the optimizer never has to worry about like, oh, do I have to take into account constant folding? It can always just assume that all that's been done already. So that's like,
canonicalization goes even further than that, to where you typically, if you have a commutative instructions, you bring it into one form. Like if you have an add of something and an immediate, you either put the immediate always on the left or always on the right. That way you only have to check one of those cases if you're like folding add expressions, because that way, if you don't do that, then something like 3 plus a plus 4 won't get folded. But if you canonicalize it and test for that pattern, you only have to test for one, and you will be able to fold 3 plus a plus 4 to a plus 7, or 7 plus a, because it's commutative.
Right. So there's like a couple of reasons, but if you don't want to go with those philosophies, you're welcome.
Yeah, this sort of trivial constant folding, typically there's no reason to not do it, and there is no way to turn this off, for instance, in LVM or GCC. Like, even in O0, there is no way to turn that off.
That's what bothers me.
It goes much further than that. Like, even if you try to divide by an integer that's known at compile time, GCC will always emit a multiplication for that, because it knows how to do that properly, and the multiplication is a lot faster than division.
Which is an optimization.
It's the worst operation ever. So a lot of these things are just, there's no reason not to do that. It doesn't aid in debugging because you're not going to debug your goddamn equation. You'd have to debug your math, and the computer's not going to help you with that. So there's no reason not to do it, and there are a lot of reasons to do it. It will just make things easier on the long run, and a lot easier in the instruction tables. We don't have to deal with nonsense adds that the architecture doesn't support.
Yeah, I definitely see where Lens is coming from. Like the inability for the compiler to generate a division by a constant, like that does seem a little bit odd.
Well, it's not that it's unable to; it's like it doesn't want to, because there's no reason to. It's like saying if I need to emit or certain things, like if I need to multiply a register by 2, I can shift it to the left by 1, but I can also add it with itself. That just does the trick. Or if I need to multiply by 3, I can shift left by 1 and add. I can shift left by 1 into another register and add it to itself again, or something like that. Because that is. Oh, actually, no. For that, I can probably do a Leah and multiply by 2 and add itself, or stuff like that. There's some for these cases like multiplication with very small integers. There are some patterns that they can use, and the compilers use by default because there's no reason not to. They're equivalent, and they have the same result. They're faster.
But to me, that's an optimization.
Right, it is an optimization, technically speaking. But in terms of doing it unconditionally, to where it almost doesn't seem like an optimization if you do it unconditionally, then it kind of just boils down to whether or not you care more about the behavior that your compiler outputs, like as in the actual executable, or the source of the executable. In other words, the actual machine code that it outputs, like the behavior or the machine code. Which one do you care about more?
And the thing is also that typically the only argument I can find, which isn't even an argument, for preserving it, is that you would be able more, and that's wrong, but that's an argument that someone might come up with, is that you would be able to better map the generated assembly back to the source code. But that argument doesn't make sense to begin with, because typically some kind of statement or expression in the source language will be converted into several instructions anyway, and sometimes multiple expressions will be converted into one, so that there is no one-to-one mapping to begin with, so that there's no reason to preserve it. There just isn't an objective good reason to preserve it. It doesn't help anyone. It only makes our lives as compiler writers worse. Users don't care.
It's a philosophy.
Yeah, philosophy is not an argument, it's an opinion.
You're right, it's an opinion. I fully agree with you.
The fact is that it will reduce the amount of cases we have to deal with in the backend and in the optimizer. And it's very easy to implement this in the CodeGen front end, because we're already generating everything with macros anyway. So it will be trivial to just add that.
I mean, so how many things are you doing in the lowering pass? Because to me, constant folding is just part of the lowering pass. And if you're lowering anything, then you can't represent the thing that you're lowering anyway, so the argument just becomes moot.
No, because the lowering currently does some very cursed things where I believe to add two immediates, it loads one into a register and adds them or something like that. Or what does it do?
Oh my gosh.
Well, that's part of instruction selection per backend. So for the x86-64 backend, we have the instruction selection pattern.
Two immediates.
Well, I guess if we're thinking of different stages of lowering, then, because I'm thinking lowering either before or after Sema, but before CodeGen, into a subset of your syntax or your Sema.
There we go. That's what he's omitting.
Oh
yeah.
What?
It's pretty simple. You have an add of an immediate to an immediate, so you move one immediate into the result register, and then you add the other immediate into the result register.
Yeah, exactly. There's a name for that. This is called a pessimization.
Right. Yeah. Is that useful or?
No, it is not useful in the slightest.
Oh.
This is just bad.
It's
what I would instinctively see is when you actually see a MIR add with two immediates, you just immediately Or actually, you would just generate the move, I guess.
That is
and then you would just
still
calculate.
far too complicated. The thing is, there's a reason why LVM does it very easy. If you attempt to create an add instruction, and the two values are constants, if it can fold it, it will fold, and it will not return you an add instruction. It will return you a constant.
Oh.
That is the easiest way of doing it, because that way you never even generate an add of two immediates, which means you never need to consider the case of the operands of an add being immediate ever. Because even in the optimizer, when you fold some things, when you inline a load or inline a store or whatever, you inline the initial value into a load from loads because it's never stored into or whatever. If that becomes a constant, you then need to create an add of two immediates. And if we actually used our functions for that, that would also happen automatically. So if we just do it in one centralized way, that just gets rid of that problem forever. Sure, currently we are overwriting and reusing II instructions, so we'd have to do that manually in the optimizer, that's a bit scuffed. We probably want to either just create new instruction for that or just override old ones or find some way of doing that. But that's really the least of our problems, because that is additional cases introduced by the optimizer. This would get rid of a lot of cases that the optimizer would have to deal with on top of that, and that the backend have to deal with right now, even if we're not optimizing. So if we think about it, if we add this to the Cogent front end, does it make anything worse or more complicated? No. Does it make anything simpler? A lot of things, because suddenly a lot of cases just fly right out the window. For instance, this rule, you could delete that one. And all the other ones that use two immediates or more. That just wouldn't be a problem anymore.
It's just
we'll not have to deal with that ever.
It's a philosophical issue for me.
It's not an argument, it's an opinion. Unless you have a good
It is
argument.
an opinion. So I fully agree with you. There's no technical good reason, but it feels, this is just, I'm going to try and put my feelings into words. It feels stupid to have a compiler that can't add two numbers. That's my opinion. It is an opinion.
That's the whole point. It does it for you. It adds two numbers because it can add two numbers, because it sees.
It's relying on another compiler of the implementation language to do that.
Well, no, it's actually the executable.
That's not the right way of thinking about it. Because what you're actually doing is you're relying on the CPU, something that has nothing to do with our compiler, to do it for you, even though we could do it. What you're doing here is you're relying on the CPU to do it.
Exactly. Just like we rely on the CPU to do every instruction that represents the program.
But there is no point to doing this.
Okay. So by default, there's no point. I agree, by default, we should have it folded so that people's code is in general faster.
It's not about people's code being faster. It's not even about that. It's about making Cogent easier. That's the main reason.
See, but then when you say easier, all you're saying is you actually don't want to be able to code gen all programs. You just want to reduce the number of programs that you can compile. But I want to increase that. I want to have the compiler compile as many programs.
Right. That is not a good way to think about it, because a better way to think about it, as in my opinion, and that is an opinion maybe, is if you think about a chess engine, for instance, one thing that is done is we have a transposition table. If you've encountered a position before, it's just that it resulted from a different sequence of moves. You don't analyze it again. You just treat it as the same. You attempt to reduce the amount of states that you need to represent.
Yeah.
So that you have to do for your computation. This is the same thing. It's not doing this does not reduce the number of programs it accepts. It just reduces the number of representations for programs that it has internally. And there's no reason to represent two equivalent programs differently.
Very true. Actually, one thing I would go even further is if it was like not terribly like for instance, if modern CPUs had multiply instructions, but they were just really, really slow, then like I would actually say only having addition in your MIR and then just doing looping is better than generating a multiply instruction, because it's actually equivalent to doing a multiply, because you can represent a multiply with just branches and addition, both of which are already in the IR.
thing that GCC is doing with converting divisions to multiplications. You
Right.
could argue that that is more of an optimization, though, because it implies a more complicated transformation that is not trivial. But this is a trivial thing to do. Like with the division thing, you could argue that's a lot more things that we need to implement and test, sure, but this is not the case. We're just removing cases here. We're simplifying. It's a simplification.
I mean, like the addition, or like taking a multiplication and turning it into additions example, that isn't even like an optimization. That's like just straight up like a sort of
I know, but what you're
transformation.
describing is
Yeah.
more similar to the thing of turning divisions into multiplications.
Right,
And you could
right.
argue, you have more of an argument that that's an optimization. That is not the case here, because this is not done to make code faster primarily. It's done to make our lives easier as compiler writers, because we're reducing the number of possible programs. With that, like, we're still accepting the same number of programs, we're just reducing the number of programs you have to deal with internally. Saying that that is equivalent to the compiler being able to represent fewer programs doesn't make sense, because that would be like saying, oh, we have this enum and we have 27 enum values, 10 of them are the same. Okay, it's just, and not even meaningfully where they just happen to be the same. No, we have foo1 and foo2. Sometimes you have to use foo1, sometimes you have to use foo2. They're actually just the same. There could just be one foo. Like, they are completely the same thing. There's no reason. It's not two values that happen to be named the same. They're just two values for no reason. That's what this is. They're just and there's an unnecessary amount of instructions there that just don't need to exist. An add instruction of two immediates does not need to exist.
That, I mean, that, like, philosophically speaking, that's exactly what I was trying to say. Basically, if you, in my example, if you don't even need a multiply instruction in your MIR, don't add one. If you don't need an add immediate instruction in your MIR, don't add one. If you don't need like tons of these different other instructions, like divisions or any other instruction that you could think of, don't add it. Because basically, the simpler you make the MIR, then the simpler the language that you have to, even though it may seem like you're discarding whole fleets of different programs that the user could write. You're not. You're just representing the behavior in a simpler language. And that's important, because the simpler language that you use to describe the abstract computation that's happening, the better things can be optimized. Like the simpler that language is, the better, or just the more optimizations can be done easier and with less bugs in them as well. That's like that's like a big thing. You want it to be super duper simple.
The reason why this is less of an optimization, because optimizations are often about transforming one operation into doing something that is equivalent but different, but just faster. This isn't the case, because replacing 2 by 2 by 2 plus 2 by 4 isn't an optimization, because that's a mathematical fact. That is, it is the same thing mathematically, really. The very same number. So
it would,
it's not,
it's
you're
not,
doing
so-
some multiplication by some huge constant so that it wraps around, and because of modular arithmetic, it's the same. As
This is
division.
where the philosophy differs. If somebody, okay, here's my extreme case. There's a hardware, like you're writing for some 1980s old chip, and it has a bug in the division that makes a certain, like, oh, when you divide by 0, it will actually return this certain value and then put the CPU in a certain state to allow you to do this other math thing. So you need to generate a divide by 0. So in my head, when you're writing, right, so then if you always have it replaced, like, oh, division by constant, obviously a divide by 0 has other problems. So it's not a perfect example, but imagine like you divide by 337 and it does this, and it puts in this other register, does this specific thing, blah, blah, blah. When the user writes divide by 337, they are not saying they want the mathematical result of this, even if it's like replacing it. What they're saying is they want the computer to do this computation, and they want the result of it. So when they write 2 plus 2, they want the computer to do 2, load 2, add 2 to it, and return that result, even if it's wrong.
There's a problem here. There's a problem with your argument, and you're arguing there's two parts to this. First of all, what you're saying, apart from the 2 plus 2 thing, is perfectly fine. And a better example of that would be if you divide by 3 and then multiply by 3.
Yeah.
If you have 10 divided by 3 is 3, multiplied by 3 is 9. So just optimizing that away is not equivalent, especially not if it overflows. So that is not something you can do. That would not be a valid optimization because that would change the behavior of the program. You're perfectly right that because the CPU in that case does not do the same thing as maths, you're not allowed to even change that. It wouldn't even be an optimization. It would just be wrong. It would be wrong content. You're very right about that. However, that is not the case for 2 plus 2. And the reason for that is very simple. The CPU can't actually add 2 and 2. It
It
can't
can't.
add 2 meters. There's no instruction in the CPU to add 2 by 2.
Like
The thing-
even if
Add 2 by
let's
2,
take like the
add
division.
2 by 2, yeah. There's
Like
no way to do that with the CPU, so you can't argue that the CPU would do something differently. Because what you're describing is, what you're doing here is you're not adding 2 and 2. You're moving 2 to a register, and you're adding a register to 2. That's very different than mathematically adding 2 by 2.
right. Like well, so the example that Lens gave though, I think from what I understand, you're taking let's say some register and you're dividing it by 137, right? And that triggers the CPU to go into a certain state.
Mhm.
So I would say that that's not a division instruction. That's a division and some other thing. It has other semantics. And so here's the difference between a compiler and an assembler. An assembler, its semantics, like the constructs that it has in an assembly language, they mirror the machine semantics exactly. A compiler, though, the job of it is to take the semantics of, for example, a division in your language, intercept. It takes the semantics defined purely in that language and tries to map it to the hardware instructions or like the actual machine code and its semantics. And so if the division instruction, maybe it's called division, but its semantics are actually quite different from the language's semantics, then the code gen should know that. A good compiler code gen will know the difference between semantics of its machine instructions and the language instructions. And so it should then take that into it. And so any optimizations that it does need to take into account that difference in semantics, basically.
Right.
Mhm.
The philosophical part just comes down to what are your language's semantics. And so like
Right.
the division by 337 doesn't really matter if your language's semantics aren't the same as that instruction. You would never generate it.
I would like to, before we stray too far from the point that I was trying to make, because what we two were just saying is perfectly correct. However, it has absolutely nothing to do with the point that I'm making, because that's more similar to, that's an you could argue that that's an optimization. However, it's completely different from adding 2 with 2, because the difference is you're talking about the behavior of a CPU. I'm not talking about a CPU. A CPU is never adding 2 and 2 if you write 2 and 2 in your compiler. The thought is always that the compiler will inline this computation, that this computation will never make it to the CPU, because the CPU doesn't even have the means of adding the immediate 2 and the immediate 2. The CPU, you can move an immediate into a register, you can move 2 into a register, you can add 2 to a register. You cannot add 2 and 2. There's no circuit on an x86-64 CPU that is capable of adding 2 and 2, and I doubt there is any circuit that's capable of doing that anywhere, in terms of you can't encode an instruction that has 2 immediates and add them, because that is nonsense. Why would you ever encode that? Like, the CPU vendors don't do that for a reason, because they expect that a compiler is clever enough to do this very basic conversion by itself. So
you're saying that
you can't argue that you're trying to emulate the behavior of a CPU, or even argue with anywhere near anything related to the CPU, because this computation is impossible on a CPU to begin with. So you have to compute 2 plus 2 yourself if you want to preserve its semantics. So you can't lower it to the CPU, so you have to lower it to something equivalent. You can't emit 2 plus 2. You have to convert it to something equivalent anyway. So what we could just do is convert it to something equivalent that's simpler, such as fall, because we have to convert it to something. We cannot emit 2 plus 2. So it doesn't make sense to try to stick to emitting something that is close to 2 plus 2 if we can just emit fall. There is no reason to do that.
The one thing that makes Lens slightly, or I definitely correct me if I'm wrong, but the thing that makes Lens slightly uncomfortable about lowering it, essentially translating the semantics of writing 2 plus 2 in Intercept, translating those semantics into the semantics that actually exist in Silicon, which is only like register immediate or register operations. Translating that in a way that makes the add happen at compile time, versus runtime. Because here in this mir add I1 immediate definition, the add is happening, or a addition of some sort is happening at runtime, which is good because you sort of know that the addition that you wrote in the source is happening at runtime. The compiler's not doing it. But technically speaking, there's no reason to really prefer one translation over the other. But like whether or not the addition happens at runtime or compile time, those are both valid lowerings to the actual silicon that you have to work with, which doesn't have an immediate instruction.
That's a great way to put it.
The two are equivalent. The two are equivalent. I'm so not saying what you're doing is completely wrong. It is a valid representation of the program. I'm just saying that you're overcomplicating it for no reason. That's the only point I'm making. Two reasons, because it's overcomplicating it in two different ways. One, it puts a lot more strain on the Cogent backend. You've had to write a lot of the Cogent backend. You've probably had to deal with immediates like these a lot. I mean, you've probably managed to remove most of it through this instruction selection, but this is not far from ideal either. You need an extra register for this, and you've also had to implement the register allocator, so you know how annoying it is if you have too many registers in there. So from a writer's point of view, I'm almost done. It's already annoying enough from having to deal with all of this in the back end. But the thing is also that there is no reason to perform a computation that could be performed at compile time at runtime. The only argument you could possibly make is that it takes too long to compile. It does not take too long to compile and add. It would actually make compile time shorter because you're removing 2 AST nodes and replacing it with 1. Or not necessarily 2 AST nodes, but like 2 II instructions and replacing it with 1. These are not some complicated template instantiations where you have to instantiate 374 templates, run 64 meta programs that end up instantiating 1,000 types, and then you maybe get a 42 out at the end. This is one instruction that actually ends up generating less IR, fewer IR instructions. Or at least it removes them from the Cogent backend has to deal with fewer IR instructions. So it only makes things simpler.
I think I identified a good way to articulate my opinion now.
Sure, go ahead.
Basically, the fundamental difference is that without optimizations, I expect that everything in the source would happen at runtime. Because things happening at least, unless like the language has compile time semantics and stuff like that, and it's explicit, but like there should be nothing implicitly just like, oh, we did this at compile time to make it simpler or to fix things. It's like everything in the source should be represented in the final execution, which is an opinion. Second of all, I think the reason for this is because the reason I feel like this is because when I write like 2 + 2 in intercept, I want to imagine the code that gets transformed into. And if it just gets transformed into 4, that's not transforming into code. That's just doing math. And I can do math. That's not, that's not what a compiler does. Is this making any sense? It's just an opinion.
I can sort of see what you're saying, but also with the arguments against. So back to the first point you were making is that you want computations that you write to be performed at runtime. Was that it again?
Yeah. Why?
Yeah. So
because it's not optimized.
The thing about this is that why would you care whether? Okay, so there's one counterexample that if, for instance, take the size of a type, how are you going to perform that at runtime? You really can't.
Well, that's a compile time operation. That's what I was saying. If there's compile time semantics in the language, like if you have a const eval or something like that, then it's gonna happen at compile time, even without optimizations. That's like what that means. That's what the programmer wrote. That's when they wrote that expression, they said, I want this to happen at compile time. But if they write 2 + 2, they didn't say they want that to happen at compile time unless they say, please optimize my program.
Well, no, most people expect when they write that it happens at compile time. No one is going to expect that if you write 2 + 2 in a C compiler, it will actually admit that. No one writes.
I have personally been annoyed, like going through Godbolt, trying to get a compiler to just emit something.
This is something that I've noticed you doing a few times, and it might be that you haven't quite figured out how to do that exactly, because the thing is, to trick a compiler into doing the unoptimized, what you might call the unoptimized thing, you have to do it in such a way that it doesn't have enough information at compile time.
Which
For
is
instance, if you
stupid.
wanted to
Why do I have
not
to trick the compiler to
operate-
add 2 numbers? It's stupid.
because it's stupid to add 2 numbers at runtime.
So
Because the thing is, the only reason why you care about that right now is because you're a compiler writer. You want to see how do other compilers do it, so you can figure out how do you do it. But as a user,
that's
you
what
would
this
never
compiler's
want this to happen
for.
at runtime ever.
This compiler is for, like, it's hobby compiler writers. That's who this is for, to see how code transforms into output code. It's like, that's why it's
Sure,
made.
but the fact of the matter
It's
is
what we
also
do.
that folding constants like that is a part of compiler writing. Just like phi's are a part of phi is also just an optimization. If you want to argue like that, why are we using phi's? We could just emit something to temporary variables, because that's
Well, because we have if expressions, and we didn't have phi's for a long time until we had if expressions where they actually return a value. And that would mean that we have to generate locals or temporaries ourselves. And instead of doing that extra complexity, we chose to go the phi's. So we had a problem and we had to solve it. That's why we have phi's.
well, but there's no reason. There's no good reason to not do this. And the thing is, you may have an opinion, but an opinion is just an opinion, and it's okay. It's okay to be wrong, but it's just a fact that there is no good reason to not inline it. And unless you can come up with a good reason, then what you'll have is only ever going to be an opinion which stands, and this is a fact, stands against what everyone else and everyone else who works on Clang on GCC. Those are very talented people that know a lot more about compilers than you or me, and everyone agrees that there's no reason to do this at one time.
Hey, can we just add a don't fold constants flag and go write code again? I remember when we wrote code on this stream.
It's a philosophy stream now.
Oh boy. I'm over here trying to read how to add custom fonts to tech, and then I'm chiming in on philosophy and
Okay,
I don't even know.
let me interrupt you right there. If you want to use custom fonts, use Zalatek. Do not
Yep,
use
I
PDF.
am.
That is
I am.
pain.
Okay, cool. Already doing that. Next.
That's a good start. Then you use package font spec, and then you call set main font and give it the font name.
Well, I don't want main font. I want it to be a font that I switch to for a couple words at a time.
Make, what was it, new font face or whatever it's called, and then you
new font family. I could try face. I'm trying family. So what I've got right now is new font family. I've named it and I've given it the font name. And then I did somebody's trick of new environment to name it and have the new environment always enable that font. So then I've got begin that environment command.
I forgot what the exact command is. I rarely have to use it, and I always copy it or look it up. But there is a way to define a command that switches to a new font. You can do that. It's
which is
simple.
I'm using new environment right now, but somebody else said you could do it with new command as well. Let me just share what I've currently got that isn't working and fucking.
Oh, I can help with now. Yeah. Anyway,
do it in a text chat, not in voice.
The LVM backend, but just for future reference, pretty much everything would suggest that it's a good reason to add this to the Cogent front end, to simply fold immediates, because there's never a reason not to do it.
And I think doing that by default is fine, but writing the compiler in a way where we take on our IR can't handle an immediate plus an immediate because x86-64 can't represent, like, that doesn't make any sense to me. We should still be able to represent at every level of the compiler an immediate plus an immediate.
Add a no folding.
Okay.
But by default, by default we can fold. That's fine.
Yeah.
So that's sort of, funnily enough, if you minimize the terminal and look in the background there, at the LVMIR, if you look at line 6, we have an add of an immediate with an immediate. LVMIR can represent that. It's just when it actually creates that instruction internally, it will fold it. So if you want the IR to be able to, for instance, if the user is writing IR, if you want them to be able to add two immediates on that level, sure. And if you really want to, you might want, as a sanity check, if something goes horribly wrong, okay, feel free to keep in that horrible clause in the instruction selection. I'm fine with that if you don't want to remove that. So it may then not end up reducing complexity as much, but it will certainly stop being a pessimization if we just add this to the CodeGen front end, so that when you call IR add and pass into constants, it gives you back a constant. If we make that hard coded with no way of disabling it and leave everything else as is, that I'd be fine with. Because making the compiler able to handle that in the backend, if somehow one of them slips through the cracks, okay, that you could make an argument that for the sake of program stability and like defensive programming or what it's called, that is an argument to be made that you might want to keep that, and I'm fine with that. But I don't think there should be a way of disabling it, that when you create an IR add, when you call the IR add function from the CodeGen front end, and you pass into immediate, that it ever gives you back anything other than an immediate.
Right. Well, so there is one other thing I just thought of, which is a different way to solve the problem that I think you have a problem with, Lens. It's so when you're going through, let's say, a God, like some compiler Explorer Godbolt thing, and you're looking for particular instructions to be generated, or really you're just trying to understand the actual like assembly output for a given piece of code. And the compiler keeps on like completely removing certain parts of it that you actually want to appear in the output, or like you're trying to make it actually generate a particular instruction. Am I correct? And that's like the main problem with like always doing this constant folding.
That is a major problem. I don't know if it's the main one. It is a big one. So the problem is, like, if I'm writing a program that's just 2 + 2, like the reason, and then I compile it, I want to be able to see the code that would represent 2 + 2, right? And I understand that you could argue that, like, oh, the code is just loading the for immediate. But
well, actually, so I do have a solution, which is that so that, for instance, tackling this kind of problem is something that I'm doing currently in my language as well. But the language essentially takes the whole compile time thing to the extreme, such that if essentially any arbitrarily complex piece of code that can be boiled down to a single constant at compile time is basically, and to avoid like the entire program just being reduced to like a single like return statement or whatever, I added this one construct which is just called use, and use is just this operator that you put before an expression, and if it's before the expression, then essentially it's treated as if the output of the expression was put into a volatile global variable, and at that point the compiler can't do anything, right? It basically just has to treat that like a black box. And by just putting certain uses statements in a particular expression that you actually want to be generated and like actually see its output, then you're essentially able to sort of by default, quote unquote, always do the maximum amount of compile time optimization. But at the certain points in your program where you actually want to see, like, is this being CodeGen for, you can put a use statement, and you can actually force the compiler to essentially disable optimizations on that point in the expression. So that was kind of the compromise that I found, at least with my own language. I don't know, I might have slightly different philosophies, but like to allow for you to actually see the CodeGen output and like not just have it be, return 42 or whatever, like boiled down to a single constant, but also make things as compile time evaluated as possible. So I don't know if that sounds like something that would also fit in your language. Probably not, but that's like another way of going about it.
The problem
is also I wasn't fully listening because I was answering a latte question just now in linguistics. But one more thing that I wanted to add is, if you want to see, if your argument is that you want to be able to see the CodeGen for what it outputs, well, the thing is that you can find an equivalent intercept program that basically does the same. That's just, if you add a variable to 2, it will generate an extra load for the variable, sure, but after that it will generate exactly the same code as adding 2 and 2, because the thing is, it has to, if you're talking about assembly, if you're talking about IR, okay, that's different. If we want to see what assembly it outputs,
that's a whole different instruction selection pattern. It could be anything. You're right, in this scenario, that's the case where it is, oh, it's only one extra instruction, it's easy to distinguish, but it could just be different instructions entirely.
But we're not talking about different things. We're talking about 2 plus 2.
That's what I'm saying. It could be when you add two immediates, it could be a different instruction than adding an immediate to a variable. We could use Leah for that.
No, you can't actually. Pretty sure.
That's my.
The thing is-
It's an analogy. I'm saying it doesn't have to be an add. I'm saying it's a different
thing
instruction selection pattern, and the output of it can be any arbitrary instructions, and they're going to be different because they're two different
Why would
patterns.
you want that ever? Why give me one reason why you would ever want to compute 2 plus 2 at runtime? And I'm not talking about compiler development. That doesn't count.
Because I'm a curious coder and I want to see how a computer adds two numbers, and I want to run through a program that adds 2 plus 2 and step through it in GDB and see each instruction run and see the registers update and then it return the correct number.
You can't add 2 plus 2 on x86-64.
You can see
can't.
the assembly that would be run by the expression 2 plus 2. You can do it at runtime. It's an add operation on the literal 2 and the literal 2. That's not possible, so we lower it very slightly to make it possible within the hardware architecture, which is exactly the point of MIR. It's a different pattern.
Well, you still can't add 2 immediates in x86-64. You can move one into a registry. You can add immediates to a
We're
registry.
saying
So
the
you're
same
technically
thing
correct.
every
You just said
minute.
the same thing, Soraid. You said, oh, you can do this on you can't add it on x86-64. I said, I know. I'm saying that it's the closest representation to how you would add 2 plus 2 on x86-64 so that they can see how a computer might get the result of an expression that they have. And then you said, in response, x86-64 can't add two immediates. What does that add to the conversation? Why do you repeat what you said?
Of trying to emit that at runtime.
I think he means there's no silicon that correspond like in the hardware.
Oh, I know what he means. That's what my first response was. So why do you repeat it? Like, I know that. He said it already.
Right.
What I'm saying is that it doesn't make any sense to the computation at runtime.
Except
I don't.
when
It doesn't have to make
does.
sense to you. I don't care. I'd like to step through it in a debugger.
Once you find out how it works,
You're an
you don't
idiot.
need. You know how it works. There's no
It
reason
doesn't
for you-
matter if he
They
knows
might
how
not.
it works. You
They
want
might not.
readers to know.
Dude.
Lens, I'm on your side. I'm so tired of this conversation being in my ear
Thank
holes.
you. Me too.
Can we ban people temporarily if they bring it back up again?
No.
I would love that.
It's
Give
fine.
me that power.
I am on Thread's side actually, but I do see very, very strongly why you so desperately want to see the actual cogen in a certain way to be able to step through it for pedagogical purposes. Like that is extremely powerful, right? Like
Yes.
having that ability in it.
Add a
But
flag.
I think
No
that
lowering.
right, yeah. But like, I mean, not to toot my own horn or anything, but I think adding a use, it doesn't have to be called the use, but like, don't optimize keyword or whatever, inside of an expression to only do that for portions that you actually want to look at with a pedagogical magnifying glass.
That would
And-
be very annoying to deal with in the past. Sam, I don't want to do that. That would be horrible to deal with.
It wouldn't be
That's
that
like-
bad. It wouldn't be that bad. Even if we
would
did
be
that,
very annoying to
the problem is
optimize
the source code would be different based on, like, that's not the expression 2 plus 2 anymore. That's the expression use 2 plus 2.
Yeah.
Like, that's different now. I want to see just 2 plus 2 and how that works.
Is it so?
Then what I will say is the last thing I'll say probably is that I'll close this
Thank God.
discussion more or less with my point of view is very simple, that there isn't absolutely no point in doing it. However, your argument being that you want to see what it looks like, fine. I suppose that may be an argument for you. The thing is, it's simply not an argument for me, and that might simply
Great,
be.
it's not your compiler.
I'm talking that
You've
might
been doing a lot of it. I'm fine to interrupt now.
that might very well. I'm trying to explain something here. Could you
Yep.
please stand down for a second?
I try.
To say is that it might very well be one of these things where I simply don't think it's necessary, simply because I'm too used to it. Because if I look at code, I don't see code, I see an EST. So I know how it works. And the same thing goes for something like C++ error messages. If I see an error, I know what the problem is. But I've also been told by Lens, of all people, that some of the errors that I think are obvious are simply not obvious at all. So if you really want to have a way of maybe trying to emit 2+2 at runtime, which even it doesn't work, it doesn't really work, but you can try to transform it into something that sort of works. I don't see a reason for doing it, but maybe you do.
This whole
I appreciate
conversation
that.
for like an hour has been I have a product and its target demographic is 14-year-old boys. And Eternal's like, well, the 16-year-old girls aren't going to like that. And Lens is like, I know. And we've been on that for an
Well,
hour.
Here's the problem:
Well,
is
I
14-year-old
suppose it is-
boys want to impress 16-year-old girls.
It is a different.
Okay, it was a bad analogy. You know my point.
I do.
It is probably
Right.
you can call it a difference in philosophy because I'm arguing from the point of view that from a compiler developer's point of view is trying to build a compiler that works well. It makes absolutely no sense to do it. You're arguing that
We
because
know.
you're arguing that because you're interested in it, you want to do it.
It's
So
his project and he wants to do it, so he's going to do it. All of the muscles in my face are so tense.
I want to keep arguing for another hour just to annoy local. This is starting to get fun.
I'm happy. So, listen, that was a difficult discussion, but I'm glad we all went through it. I really thank you all for not giving up. You all kept trying and we communicated and we got through it. It did suck a little bit, but we now understand each other so much more because I now really understand what Saraid's saying, where it's like when he writes 2+2 in a source code file, he doesn't think of it the same way when I write 2+2 in a source code file. It's like it's a fundamental difference there. And then from like a technical point of view, I actually learned a lot because the thing is when people say like you would never need that for debugging, that always confused me because like what if I want to debug 2+2 on a hardware CPU and see what the registers are and like what? So it's like I do want to keep it for purposes and I don't understand the full technical, like there's no reason to do it, but also there is like a million better optimizations and simplifications that you can do within the compiler code itself if you don't do it. So from a compiler developer's point of view, it absolutely makes no sense to like allow 2+2 to happen. Because it just causes a lot of issues with later down the line in the compiler. But the fact is like we're already handling those and it's not that bad. It is way worse than if we didn't, because, for example, in the iCell, it's like, oh, we have to handle not only register to immediate, but also immediate to register, and also immediate to immediate, and there's all this stuff, right?
A bit harder, but because they also, I'm not so to calm down local. We're not planning on having any more heated discussions here.
Okay.
What I want to add is that that is slightly different because you could argue that canonicalization is a somewhat more complicated operation than that because there's a lot more to it, and that checking if two things can be added, especially the way we're defining it, it would be very easy to implement that in the code in front end is also what I'm saying. Not only from a compiler developer's point of view, again, for is trying to write a compiler that reduces the number of edge cases you have to handle because there's far too many already and that generates efficient code. It makes a lot of not just does it make no sense not to have it, but it also makes a lot of sense to add it in that place simply because it's very easy to add in that place and it simplifies a lot of things. Canonicalization is a bit of a more complicated step, but it goes in the same direction, obviously, yes.
And that makes a lot of sense. Yeah, so I was probably overstepping where like it's not all of these that are the case. It's probably just the immediate to immediate that we would be getting rid of. And just having that one shaved off would be easy to do. It'd shave off one from every single one of these things. We'd never have to think about it again and blah, blah, blah.
But also you could make the argument that if we just wanted to reduce the complexity of this instruction selection table, that's something I've mentioned before and that I would actually suggest doing, not just for this, is we could add macros and then just make a macro generate all of these at once. So we don't have to keep it, because this is a very repetitive table.
It's very true.
Here. So that's why my original proposal for the instruction selection format had macros. I think you may now see why. And now that we have macros and intercept, we can probably just either just copy the code or just even reuse it. Maybe we can find a way of reusing the Lexa. I'm not exactly sure how the tokens work in here. But we might want to find a way of also adding macros to this because that would make things easier.
Macros.
That's a good idea. So yeah, it would be tough. What would the actual macro? So we could have a macro that's like commutative, right?
Something like that, or even if you want to keep all the rules that add that perform an operation on two immediates, like multiply, subtract, add, that's going to be the same for all of them. Just
Right.
like x immediate becomes move, like
Yep.
yeah, x y z, where y and z are immediate becomes move x into register and then z register y, whatever. I'm confusing my letters here, but you get the point.
Yeah.
Yeah,
It'd be something
that.
like this, and then we can just handle all of them quickly.
Or even add a for loop to the macro syntax and
Exactly,
loop
like for.
something like that. Yes. So that is another way to solving this problem. Just in here though, like, but that might still do odd if I'm writing too much algo. Most people would automatically go for do done or do end, but you just wrote do odd. Yeah, that would be a way of solving this just in here. I'm not currently not familiar enough with the CodeGen backend to know if there's. Are you ever handling the case of adding two immediates in the backend? I don't think so. Like in where you emit assembly.
Yeah, we're not at this point.
Because that at that point it really shouldn't exist anymore.
Yeah, if we had like an MX64 add have two immediates, that'd be pretty insane. Because this is meant to represent the machine instruction.
There is some argument of maybe leaving this in here, even if we completely remove the ability of generating such an MIR instruction from the front end, because we might miss it in some optimization path that inlines something. Because this is, I'm not sure if you're familiar with the term, but this is also sometimes called defensive programming, I believe is the term. It's the same thing as when you are iterating over a string and you write so long as foo is not equal to end, and instead of that you write so long as foo is less than end. That will result in the same thing. It's equivalent most of the time, but in case you make a horrible mistake and end up skipping over end, the less than case would catch it, but the not equal would not. So that's called defensive programming. You choose a somewhat equivalent representation that catches some edge cases that you probably will never run into, but just in case you do once in a blue moon, you've taken care of it and you don't need to worry about it anymore. So you could leave. There is an argument for leaving this in here for exactly that reason, and that might also make the argument that it simplifies things in the back end a bit weaker. But at the same time, adding it is probably going to be a few lines of code in the front end, so it doesn't cost much. Is also the argument. That's an argument for doing it.
I'm gonna go piss. Have fun.
That's fantastic. So what we've discovered in the end is that, truthfully, we do want the constant folding in the function by default, pretty much. Maybe have that able to not happen through a command line argument. Or even by like a command, like a preprocessor directive. But also, we still want, that won't reduce the complexity of the backend necessarily, because it's probably better to do defensive programming and like assume that there's a new front end that somebody wrote and it's generating different IR a little bit.
Yeah. In that case, we'd hope that they'd be using our IR add instructions and not filling in IR manually, but still, yeah.
That's right. I like it.
Something else, if you really want to, we can try out a compiler flag for that. But the thing is, people will rarely ever use it. And the one thing, and that's the last thing I'm going to say about this, is that the argument that you want to see what 2 + 2 looks like on the CPU. The only slight issue with that is what you're actually going to end up seeing is the best attempt of the compiler to represent 2 + 2 in natively, and whether that's what you actually want is, I'm not sure.
Right. It's definitely not.
In
It's a
that
very
respect,
niche thing.
you could argue that that inlining 2+2 is actually what you'd want to see, because you can't do that at runtime at all. So the only way to actually add 2 and 2 is to do it at compile time. That would be another argument for that.
Well, actually, I would say that that's just that isn't necessarily the best translation of semantic. It's just one possible translation of semantics. And it is the most performant, but it is not the most pedagogically informative.
It
And
is a very,
these
it's a
two,
very nuanced argument, and I'm not sure it's entirely correct, because what I'm basically, to restate it a bit, is what I'm basically saying is that if you want to know what a compiler does, if it needs to add the immediate 2 and the immediate 2, then the only way to actually add 2 immediates is to do it at compile time, is what I'm basically saying, without
oh,
using anything
well,
else.
yeah,
Then
it
also
is.
the argument that at compile time, well, how do you bootstrap this? You can't add 2 immediates. How are you going to add 2 immediates? Well, at compile time, immediates are really just variables, so you never really add 2 immediates. So it's kind of, at this point, it's a question of how you define this. And at that point, I don't think it makes too much sense to really argue that.
I think it does give a pedagogical insight in terms of like, oh yeah, compilers do constant folding. That's like a pedagogical
Yeah,
thing to do.
that's another
Yeah.
argument you could make, that how would a compiler deal with that? Well, it would fold it. And I do
Right.
get
Right.
that what Len said a while back is that it gets annoying if you're trying to get Clang to do something so you can look at what LLVMI spits out, only to discover it's optimizing it away.
Yeah.
What I will say is you do get better at that, and a very easy solution is to just declare, if you want a function not to be inline, you declare it, you don't define it. So then it has no choice but to emit a call. Or if you want a variable, or if you don't want it to optimize away a variable, you could either do some as in volatile black magic, or you could just define a function that accepts that as an input, call that function, sorry, just declare that function, never define, then just call that function passing in that value. That way the compiler has no choice of actually emitting the value and of actually generating at least code for it. It won't execute,
Right.
sure, but
I
it will
mean,
at least compile to either IR or machine code. So there are these tricks that I feel like if you need to do those often enough, they'll eventually become second nature. So that's just something that you need to
yeah.
do. You sort of need to trick the compiler a bit into generating what you wanted to generate, because the thing is that you want something very unusual. You want to see what the compiler spits out verbatim, so that you can do the most basic thing, so that you can implement it in the most basic way possible. The thing is, a compiler typically doesn't want to do that, because what most users who don't write compilers are going to want is that it generates sensible code. So
Right.
that's why it involves quote unquote tricking the compiler into doing something, because you are trying to get it to do something that most people don't want it to do.
Mhm.
And in that respect, I think it makes sense that you have to trick it into doing it, even if that is inconvenient as a compiler writer.
So that's definitely the basis of like, like the approach that I'm taking in my language, having that use thing. But I think that the goal of Lens having it actually like generate sort of this very naive like register based semantics translation of the 2+2, like actually having it be register based, is actually probably not because you actually want to add immediates. If you write 2+2 in the source, you probably want to know, how does a CPU work? How do registers work? How does a add register instruction work? And like those are the kind of questions that you actually want to answer pedagogically. Speaking, when you write 2+2, despite it literally being an immediate add in the source, you actually like your pedagogical interest is in the add register instruction and how registers work in a CPU. I think that's more so what Lens is after in terms of the pedagogical like value of generating a add immediate like that. Is that correct?
Yeah, sure. I'd say that from that point of view, that's an argument you can make. And the main problem earlier was that I'm simply not arguing from that point of view. I'm arguing from a compiler writer's point of view. And if you want to learn how most people normally write compilers, you would want to teach that most compilers normally do constant folding. So
What about
what you're saying is correct, I'd say, but also my point of view, simply if you want to teach that, then it would make more sense to teach constant folding. So
Right. Yeah.
depending
Like
on
a-
what you
like a
want to
compiler
teach,
course.
you want to do one or the other. And it just so happens that what I would want to teach is generally what compilers do by default, irrespective of teaching.
Well, I mean, like what I'm saying is that these two classes, like, you know, you have like a class on CPUs, like, you know, how CPUs work, and then a class on compilers and how compilers work. Like there's these two different translations of an add immediate that you have to pick in order to actually make it lower to the hardware. And they're completely at odds from each other. One of them helps the pedagogical CPU clarity, and then the other helps pedagogical compiler clarity. And so, like, basically you kind of have to pick like which type of student are you trying to teach, basically CPU student or the compiler student, when you're picking these two different lowerings. And I think I'm kind of erring on, actually, now like hearing Lenz's like opinion on it, I'm actually erring on the side of the CPU student, because I think there's a lot more to be had there. Like, generally speaking, you don't see many compiler students that are struggling with this kind of thing there, but you see a lot of people that are like, how does a CPU work? How does a computer work?
Yeah, because I agree. Because also for me, the thing is kind of, I sometimes tend to presuppose certain things when I explain something. So for things like that, if I am explaining to someone how a compiler works or how a compiler generates code, I would never do that before explaining in detail how assembly works and everything. I would always start with how does a CPU work, and then knowing how a CPU works, knowing how even and long before that, knowing how pointers work in C and so on. Only then would I ever try to explain to someone how a compiler lowers it to it, because I don't really see someone understanding all of that at once. At least I couldn't, or at least I didn't when I learned about it. And I would say that it makes more sense that to first explain pointers and memory layer and stack and heap and register and all of that long before you ever learn how a compiler works internally. And then when you do get to that point, you already know all of that, so you don't need to explain that again. And at that point, it makes more sense to explain constant folding, which is something that
Right.
they might not know about yet, but they already know how registers work. So that is my argument, is not to try to explain all of that at once, but to presuppose that they already know that.
Exactly.
And at least I generally wouldn't be able to deal with all of that at once. So that's my approach to this. But I've also seen compiler classes and people explaining it that try to do everything at once. And it is just that, in my opinion, they often don't do a very good job at trying to explain everything at once.
Right. Yeah.
So that's another argument you could make and that I'd make.
Very interesting.
But that is, again, it's not even really an opinion either. It's just a different approach to it and different point of view even.
Yep.
So we're going to merge this now or not?
Oh, can you make this change?
What change? Oh, that change.
Yeah.
Oh, so we want to. Oh, that is my compiler. That's the wrong. I have 4 C line tabs open. It's horrible. So this is the right compiler, I think. Sure.
GigaChat doesn't even know which compiler he's working on right now.
Fine. Oh yeah, you need to catch up on chat, I think, also while I do this.
Oh, great idea. Great idea.
Could you play me not close that?
What did I close?
You close the
Mavic
view. So I now know what I need to type in. You LVM version major.
Okay. So
Okay.
by the way, I just want to give a shout out right now. This is a good time to the donators of the channel. We had Eigentourist, a viewer here, donate $25, which is the largest donation I've ever received. So shout out Eigentourist. You were a PogChamp viewer. Everyone else, I appreciate you just as much. We are all in this together, and that $25 covers many of you able to watch for free, right? So your fellow community members are helping you out. Because if I don't make any money off this, it's hard to justify spending as much time as I do on this stuff. Because the idea is I've probably put in 300 hours at this point to the of streaming the compiler, which is if we think about the wage on that, it's not minimum wage. And
I've pushed the thing, by the way.
Awesome. And it never will be minimum wage. I'm okay with that. But making it where I at least can kind of like break even, where if I don't have time to make dinner because I'm streaming all day and then I have to order out, it's like if I can cover that with a donation, then that makes it so it doesn't affect my budget, right? Otherwise, I'm just eating into.
While you merge it, because I think it's easier if I scroll up in Twitch, so I'm gonna try to respond to some of the stuff that we missed just really quickly because
Perfect, yeah.
we discussed this for an hour now or something.
Oh yeah, some people are saying that there's like Minecraft CPUs that let you add to immediates.
Sure, okay, fair enough.
It is possible in hardware. It's just you don't
It
see
is
it.
possible to do it in hardware. It's just that there's usually, and in fact, I mean, immediate. It's hard. Immediate implies if it's encoded in the instruction itself, so that's not possible in x86-64. But you could make a CPU that can do that. There's not good reason to do it. The thing about a Minecraft CPU is even being able to do that is a lot for a Minecraft CPU. So
And actually, you might not have a compiler for a Minecraft CPU. Maybe that's just out of scope.
If you guys have heard of, it's not for a Minecraft CPU, but if you've heard of Seth Bling, he did write his own programming language for Minecraft that compiles to command blocks.
That's true. You can do it, but
yeah,
most
it's theory complete. I'm sure it is. Someone wrote earlier, if
Oh yeah, it's a
expression,
full language.
yes, possible way of coding this. If expression equals 2 + 2, print 4. To do
There you
add
go.
2 + 3, 2 + 4, etc.
I mean, that's the quickest way to do it.
Yeah, because I mentioned pessimization, that's an actual term. Yes, that's the opposite of optimization. To make something worse.
Right.
Or less efficient or effective. Oh, Nihil was asking, what is the identity of a program? Is it a value or a series of expressions? So that depends on the definition. Generally, what when we're talking about optimizations, and also what things like the C or C++ standard mention, is that that a compiler is allowed to transform a program into an equivalent program, meaning it does the same thing with respect to side effects, such as it prints the same thing and so on. So you could argue that two programs that, given the same inputs, always produce the same outputs, and all their other side effects are the same, irrespective of how they do it. Basically, are maybe not the same program, but equivalent programs. So it's an equivalence relation, but it's not exactly identity. So the identity of a program would be, it's really just identical down to the last byte is how I define identity, but equivalence could be defined over as an equivalence relation over side effects and so on.
And to me, identity of a program would be like the syntactical constructs, but not the actual bytes. Like it wouldn't matter to me if you use tabs or spaces.
Sure. Okay, yeah, well, that is, yeah, okay, sure. That's, yeah, at that point it would be visually sure. If the source code looks exactly the same, yeah, you could also argue that's identity based on what the source code looks like, sure.
What about renaming variables?
Well, then it would be equivalent.
Really?
I think it's equivalent.
Okay, the difference generally is that identity really refers to one of the same thing. Identity is the simplest possible function, f of x equals x. It maps everything back to itself.
Yeah.
So two things are only identical if they are really the same thing. That's generally how identity is defined in mathematics and logic and so on. Equivalence can be a variety of things. Like things can be equivalences that you might not even think they were, because equivalences are typically defined via something that's called an equivalence relation. And for something to be an equivalence relation, it has to be, what was it? It has to be reflexive, meaning A has to be equivalent to itself. It has to be symmetric, meaning if A is equivalent to B, then B is equivalent to A, and vice versa. And it has to be transitive, meaning if A is equivalent to B and B is equivalent to C, then A is also equivalent to C. That's if a relation satisfies these three requirements and is closed on these three, then it's an equivalence relation.
I mean, that's
if it is an equivalence relation you could use the term equivalent for. And equality, for instance, mathematical equality is an example of such an equivalence relation.
Right, right. But I think usually computational equivalence is generally defined by what are the space of possible inputs to the program, what are the space of possible outputs. If two different programs have, given the exact same set of inputs, produce the exact same set of outputs for all inputs and outputs, then they're equivalent. I guess that's the quick and dirty definition for computation. But I would say that, like, even if you have two, let's say, intercept programs and you change the white space in one of them, I would say they have different identity. And so
Interesting.
They aren't
when you
identical.
talk about identity versus equivalence, you have to be really careful because, like, yeah, if you like rename one of the variables, right? Technically speaking, that changes the identity of it. But it
Yeah.
still obviously has the, those two programs are equivalent because they have the exact same semantics, they have the exact same behavior. But if you change the white space, same dealio, right? So what's the rub? So I
Identity-
actually see identity is very, very strict.
Identity really means the exact same thing. And you could even go so far as saying that if you copy a program and rename the file, I mean, the contents are identical, but is it the same thing really? I mean, that's a bit of a corner case. But general identity really means a thing is only ever equivalent to itself and only ever identical with itself and never with anything that just looks like it.
Exactly.
But they're called identical twins.
Well, yeah, language is not as precise as logic would like it to be.
Mm.
That's why mathematical notation exists and all of that.
That's a good point. Because when people say, like, 7 times 5, they don't specify, like, oh, I'm doing integer multiplication.
Mm.
No, they're saying I want 35, but I'm too lazy to, like, calculate that myself.
Exactly.
Or for readability, maybe, because if you say, okay, I want to, okay, hold on, I need to quickly compute that myself in case I'm misremembering, but I think it's 86,400.
Right. I mean, like, readability in a
For
program,
instance, if I take some value, time, and I multiply it by 86,400, what in the world does that mean? But then if I multiply it by 60 times 60 plus 64, 60 times 60 plus 24, it's days.
yeah, exactly.
You might not know off the top of your head that a day has 86,400 seconds.
Right. Yeah, that's a very good example.
So
Yeah.
and the constant folding at wherever it happens enables us to write things in a legible manner, whilst and relying on the compiler to transform that into efficient code. And that's the basis of optimization in general, because we could also just inline all of the functions manually, but it would be horribly unreadable. Like there's hardly an optimization that a compiler can perform that it couldn't do manually. It depends on the language, of course. Things like devirtualization would be an exception to that. In some cases, but there's hardly an optimization that the compiler can perform that you couldn't do manually. It's just that if you did it manually, your program would end up looking atrocious. You'd just basically be writing assembly in C++ or something. And that's not the point of it. The point of it is that we're able to write high-level code and rely on the compiler to make it performant. Because if you execute C++ literally, it is a fast language, but if you don't optimize it, yeah, it's still going to be fairly slow. I mean, not as slow as, probably still faster than JavaScript and some interpreted languages, but the speed of C++ very certainly comes in great part from optimizations, to the point where some optimizations have even made it into the standard, such as implicit move and all of that, and named return value optimization and mandatory return value optimization and all of that.
Yeah.
So the point of a compiled language is generally to optimize. Also, this is an interesting point that we haven't thought about at all that I see early in chat by Eigentourist is they're saying, I feel the need to defend the 1980s, it being the decade when I came of age. We could not afford to have math bugs in our CPUs in the 80s. It was the Cold War. We had very small registers and very small memory, but we did correct math. I maintain that the math bugs were a 1990s post-Cold War thing. So, yeah. You could have maybe that back then the CPUs, but especially back then, I could definitely see the CPUs being just not even that they don't want to support it, but they are simply not able to for hardware reasons. Because I mean, Intel could add an instruction that adds to immediates, just that no one's going to use it.
Right.
So today it would be nonsense. Back then, it may just have been too hard to do.
Right.
Either
Like it
way,
would
you
require an extra byte in the encoding or something.
Mhm.
That's a good point. So yeah, it's like it's not necessarily that was even the goal of of the like they weren't necessarily thinking like, ooh, if we don't have to add to immediates because they can just move it into a register and then do that. That was actually a required solution to a different problem they were having of like, how do we encode this specific instruction?
Mhm.
That's cool. That's a good way to think about it too.
Mhm.
Okay. I think it's time to merge.
Pablo Pepe is mentioning what I said. You have the right to be wrong. Yeah, that's something that I like. I don't know. I don't remember where I got this from. It's a quote by somewhere from something, but it's like you have you have a different opinion. That's okay. It's okay to be wrong.
I mean, you have the right to be wrong, but I don't think you should.
Mm.
So.
Right. And I appreciate that because it's like, in this specific case, I understand that where you're coming from. Because when you say wrong, you're not saying like morally, like that's the wrong way to think. You're just saying that technically speaking, there's no reasons to think that. And then in fact, there's reasons to think the opposite.
You'll hardly ever see me arguing based on morality. In this case, I was specifically arguing, we've explained that already at length, but just to recap real quick, is that from a compiler writer's point of view, wants to write a well-functioning compiler, there's no point in doing it, and a lot of reasons not to do it. Or rather, and there's no reason not to do it, and a lot of reasons to not. It's like difficult, like pronouns.
Yeah.
Basically, there's a lot of reasons to fold it and no reason not to do it, basically. Especially because in this case, it's very easy to do. It's not some complicated optimization that we need to implement and that might be buggy. No, checking if two things are immediate and adding them if they are, that's not going to result in a bug ever. I doubt we'd ever mess that up. Like that would be very sorry. I'd be a sorry excuse for a programmer if it didn't manage to implement that properly.
Right, but I think
things like converting division to multiplication can be a bit more complicated.
Yeah,
and
right.
similar patterns and so on. But this is a very basic and elementary operation.
But it's important to note that constant folding is a pessimization to CPU teaching. That's an important point, I think. Hopefully that's
exactly. Yeah.
And yeah, I mean, it depends on how you think about it. Yeah.
Yeah. So there's two different parties that, you know, you're of course trying to satisfy the compiler implementer's wants, but maybe the language itself is trying to satisfy the CPU students' wants.
I'm going to put
so it's two different conflicting. Yeah.
At the top of the description of this VOD, I'm going to put every time someone says from a compiler developer's point of view, take a shot. It'll be a fun drinking game.
Die.
I want to die. Yeah, we'll say every time they do it, smoke a joint.
One discussion about 2+2.
I won't know what a joint is in like a few minutes.
Yeah.
I'll be gone.
And then there'll be a compiler developer.
Also, some more comments in chat earlier. Simplish is saying, just tuned in. What am I listening to, Monk? Pablo Pepe said, I've to confess that I love this philosophical discussion about optimizing 2+2 on Twitch. I wasn't expecting this today.
Oh boy.
I'm glad I can provide this philosophy channel. It took us 3 hours to merge a PR.
Yes. Again, I've mentioned this before, but the amount of work that you get done on stream is inversely proportional to the amount of people in the VC with you.
It's true. But I think that I learned so much more today than if I just wrote code. Because and the thing is, I can't even start writing code because after I merge this PR, it's gonna just be like a bunch of merge conflicts,
Conflict.
and
Mm.
so I feel like I should probably just handle that off stream, because it's literally gonna be an hour of do I keep this change or this change?
Yeah, I mean, I've tried not to. A few things I've had to touch, like most of the stuff is just in the LLVM backend, but I've had to change a few. I mean, okay, then again, I fixed W conversion errors everywhere. You saw
Yeah.
when you compiled, it didn't error really, except for long nonsense.
Yes,
Because I think, are you using long anywhere?
we probably are somewhere.
You're probably using long or somewhere. Yeah, that would explain it.
We're gonna grep for long.
Long man. Did you ever watch Long Man?
There's-
Nothing. So I have no idea what's going on then. Fascinating.
Yeah.
Perhaps it could be that because of eye size and I64, it could be that pointer diff t and is long and not is long and I64 is. I don't know what's going on. One of them is long, one of them is
Oh,
long.
yeah.
Something like that. It's some
It could be the
Windows
standard
weird
implementation.
Yeah, I think no. What's probably the case is that on Linux, and I know that for a fact, is in64T is a long, but probably on Windows it's a long because
Yeah,
the long
Windows is stupid.
What's long? Did you say long man?
on Linux and
He's
in64
talking to me.
I was.
is a
I
type of
DM'd you 6 days ago when we were talking about
That's
Long Man. Did you
right.
ever watch it?
The video, I haven't watched it yet.
Damn, it's like 6 minutes. We were gonna watch it together even, so maybe after stream.
That's a good idea.
sure.
Wind down after stream with some Long Man.
I was going to say something, but I think I forgot. Yeah. Speaking of long, you can check out I think it was the some of the XA6 wherever we create the XA664 Cogent context. Wherever that was.
Yes. That's gonna be in somewhere.
I think it's just in the main thing. Yeah, if you go down a bit, you'll see that I've added. There we go. We can see I've added some stuff to that.
fantastic. Yeah.
So
Yes.
I've also set integer size just hard coded to 64 for now. That's the built-in integer type.
Oh, nice. Not the C int.
Yeah, C and is 32. And the only difference between these two is C long is 64-bit on Linux, 32 on Windows.
Yep.
It's in bits because that's easier to handle, honestly. Because you need the size in bits all the time and rarely the size in bytes of these because you're mostly converting them to whatever in LLVM. So that's why it was easy for me to represent them in bits. And because we probably should also switch. I mean, user space, I'm saying user space. Oh god, front end size of if we add a size of operator something equivalent, that should probably return bytes. But it might be easy to represent everything internally with bits because especially since we have arbitrary integers and we could have an I7 or an I13 or whatever. But I did that. We'd have to change the entire Cogent backend for that probably because you're probably using bytes. So
yeah, we're using bytes right now. We may fix that eventually.
But for now, this is bits. I even added a comment to that because this is now in the Cogent context.
That's good. This is
None
awesome.
of these are actually used except cint and integer size and point. I'm not sure if I'm using pointer size because LLVM knows what the pointer size is, so I don't need to tell it that.
Nice. Beautiful. This is awesome. We did it. We're ready to merge. I have a lot of merge conflicts to deal with. That'll be fine. Any last words? Any last thoughts?
I think it's fine.
Kiwi from Earth says Kiwi again. Hello, Kiwi.
Kiwi.
Let's do it.
Yo. Okay, it didn't blow up. That's good.
There we go. That's good. Now I can do this.
Beautiful.
I can go to my main branch.
What makes me author all of them?
Update. I can go back to main here. Pull and delete the LLVM branch.
That's right. I should be able to do the same.
And it's gone. There we go.
I now get to clone mine again.
Don't you have a copy of yours?
What? Oh, that's true.
Don't you have a copy of yours?
Yeah, that's a good
have
point.
a copy of yours. It's yours. You can just do git pull.
I can just
That's predicated on the assumption that all the module stuff is on a different branch.
Oh, it's not.
Oh
It's all right here, baby.
dear. Well.
Just gonna stash everything.
Oh no, my god. 32! What is wrong with Jesus? Why? Are the other 31 stashes relevant anymore?
They are not.
What in the world is all of this?
They're mainly me failing to implement something.
Stashes? Are you familiar with that fact?
Yeah, I always apply them because I'm scared if it doesn't apply correctly and then it also deletes it.
Jesus.
Okay. Now fetch, and then I can merge.
I was gonna say some. Oh yeah, we can try compiling some more stuff to LVMIR because that's fun. If you're interested, what it spits out.
It's probably a good time.
It'll probably spit out an LVMIR.
Oh, you never know.
I don't know why that was so funny. That's so good.
Thank you. That's my contribution to the stream. Other than stop arguing, it hurts my head.
That's fair.
We stopped arguing now.
I know that was an hour ago. That was my other contribution.
That's
Yeah,
right.
don't worry. We'll continue next stream, so don't worry.
Damn.
I'll forget all about like the resolution. I'll just remember the problem and I'll bring it up again.
That wouldn't surprise me, honestly. Like it hasn't happened before.
It could happen. Stashes.
Constant folding. What do you think?
That's what I start the next stream with.
I'm gonna open a PR for it, and you're gonna say, "Wait, why did we need this again?"
Did it? Oh my god! Did it actually just work? There's no conflicts.
Git is actually useful, fascinating. Apparently, there was no overlap at all between what we did.
Git is smart now.
I didn't change anything in the past, so I didn't change anything in Kojin except for that.
I know you changed all these.
I added an if somewhere, but down in the main Kojin thing. I added a target, but I don't think you modified those. I added something in Sema, but there's nobody inside here because we haven't dealt with importing stuff. It even then there wouldn't have been overlap. The only change in Sema was to change something about main. Did I even change that? I was gonna change that. I think I ended up having to. Originally, I tried converting the return value of main to int, but it didn't work well. The backend wasn't happy, so I left it at integer. So our signature for main isn't fully correct. However, it's mostly correct and it should work now because it wouldn't have worked early. I mean, I'm not sure if it would have worked too well earlier because we were accepting argc as an int64 instead of an int32. But actually, I don't think that would have mattered. But at least the parameters are fine now. That wasn't me.
We have an issue.
Oh no.
What did you do? The seg faulting.
Every single time.
Yeah. It's probably got to do with the module stuff.
It does. So something you changed is interacting with something I changed, and it's now causing a seg fault. Fantastic.
Fascinating. Well, we'll get back to that eventually.
Merge conflict.
Doesn't have to be now.
This is worse than a merge conflict. You're right.
Oh my god, I'm so happy there's no merge conflict.
Awesome.
Seg fault.
I didn't change much in here, I think. Just added the thing, and also at the bottom added a thing, like the default file extension. I love that ice on 317.
Oh yeah, this is the testing. And the variable name is ugh.
That's yeah, I do something similar. If I ever have to use an IO stream, or an F stream, I typically call it heresy. Because it goes against everything I stand for.
So I guess the question would be, does it have to do with us reading an object file? Because I can see how this may cause some issues based on. I guess it shouldn't, but if that, what would have to change? Yeah, so this did cause everything to work though.
Okay, so now we can test it.
Yeah, but it's confusing. Why did this fail?
Something was null somewhere in that code that we haven't really tested much, and that is far from complete right now. So
At least it makes
not-
sense. Hey, oh, that's
there we go.
it's not great, but
Yeah, we'll get back to that.
so
I have to compile with Clang for that to work. Oh, you don't have to
Yeah,
compile
every
with
time I
Clang.
do it.
It works if you just. That's fine. Yeah. You just have to use Clang, so that should work. Just the declaration.
Okay, I'm just curious, what did that actually give me?
Not much.
So why did that fail though?
The test failed probably because it didn't return 69.
Should it return 69?
Well, yeah, probably.
Oh,
Funny. Oh, this one.
I remember now.
What was this one again? Forgot.
Yeah, so basically this is meant to return 69,
Ah,
and right now it's kind of just returning. It's not like
Garbage.
yeah, it's returning
and
anything.
now the declaration doesn't return a value currently. Right.
So
Is
we're
that
just
it?
yeah, we have like UB where this return value, but type checker doesn't call it an issue. It still assumes declarations that return a
What we
value.
actually should do is return the thing that the declaration. Yeah.
Yep,
Yes.
that's the intent, but it does not do that.
Yeah. That's what I do in my language, and that's what I assume this should do. Yeah.
And I am assuming that it actually does return 69 by happenstance because like we move this into racks and then we return. Maybe.
Something like that. Who knows?
Or I don't know why we wouldn't just put 69 here, but I remember we
had
had
a
a
discussion
reason.
about it being wrong intentionally to remind you that it was wrong, which is
Yeah.
probably what reminded you of what you just remembered.
Yeah. So let's leave it at 420.
It should, even if it accidentally works, it should still fail because it's not officially supported by the compiler. And when you officially supported it, you would change it to 69.
That's right.
And
That's right.
you can also add a comment above the line 69 that says something like the declaration should return should load the value or whatever.
Yeah, should return the stored value.
Yeah, something like that.
Yeah, it's funny that we didn't put this kind of comment in there and we just left it implicit in 420 and 69 and had to remember it all. It's almost like we support comments.
You can put a lot into 420 and 69, let me tell you.
We did just unpack a lot of information out of it, so
Yeah.
you're not wrong.
It took us a moment, whereas this should be faster.
Obey your master.
Did you say something else in linguistics about LaTeX? I wasn't looking. I was too engrossed in our discussion.
I fixed the problem because what I forgot was I installed the font on my Windows box, but not in WSL, and I was running ZLaTeX from WSL, so I had to just go add it to the fonts folder.
Did you add the declare text font command? I didn't even know that existed. I always just do def for that. That's cute.
Yep. So that's what I'm doing right now, and it looks to work
That
now
is
that the
what I
font
would
isn't.
do, yes. That is how I would do that. That
That's
is easier than doing the
Mhm.
environment.
Yep.
You
So
broke
that's what I'm doing now.
Gents M.
But now I'm overthinking restructuring my temporary document. Like I'm not trying to write a perfect reference, grammar, etc. first, but my brain is like, you're never going to change these sections again. And I'm like, it's text. I can copy paste it. It's like, no, once you write a section, it's there forever. You got to do it right. I'm like, stop.
What are you looking at?
You broke something.
What? I didn't change the parser. What do you mean?
I may have
Failed.
broke something.
I didn't
We
change the
broke
parser.
something.
I changed the parser. I don't think I did.
You're probably right. So it's saying that parse ident expression is being called, but the context isn't an identifier token.
Yes. Also, why isn't it printing what the token is? Can our assert not do that? I forgot.
I mean, we don't know what it is. It's just a token type. We could print like the token type to string.
That's what I meant, but also this is an assertion. So the thing is, the idea why this is an assert is that this should only ever be called if we have made sure that it is an identifier. So there's probably like some weird fall through or something somewhere. Or where it
Exactly.
decides the token or shouldn't be. So I don't think this is really necessary. And I'm also not sure if assert even supports that.
What?
We're about to
Does
find
assert
out.
support a format string?
It should.
Also, what does token type to string return? A span or a char pointer?
It's a char pointer.
Okay. We can check what assert does, I suppose. Let's see. I need to scroll every time we need to scroll past the test. That's annoying. Where even was that in the goals? Where is assert? Hold on.
It should be like raise fatal error impl or something.
Oh yeah, I remember that vaguely.
First
Where
time
the hell?
chat from Yukape3024. Compiler from scratch. Damn.
It could be an error page. That's the thing that exists. Yeah, it calls raise fatal error impl with, and that's
Should
format
have
thing.
formats. Yep.
No, it doesn't. Oh, it does, but it just doesn't support.
It's
Fascinating.
called
For some
with
reason, raise
Jensen.
fatal error impl doesn't have the ext format thing on it. I have no idea why it doesn't.
Interesting. That is weird.
Do we? That is very weird. We use eprint.
Oh, it's right here. Am I forgetting to go to the next token? What's happening?
Okay, let me take a look at this. TK Jensen. Yeah, that wasn't me.
Yeah, it was me for sure. I don't know why it's now an issue and it wasn't before.
String generated sim, vector back, vector append, pass ident expression. Yeah, the gensim isn't an ident. That's the problem.
So, what are we trying to do? It matches token identifier handling. Shouldn't we just say vtalk type
You
equals
could.
token identifier?
Yeah, you can do that. That's one reason. The other is to allow gensim in pass ident expression, but that's also a solution.
Okay, we'll try this.
Yeah,
We're gonna
they're equivalent because it discards it anyway. So, but yeah, that would make sense because it's a different token kind.
That does. I forget. Okay, that worked. Hey.
69.
Okay. Fantastic. That helps solve that thing.
Oh, by the way, because we briefly mentioned the test runner earlier, I wanted to kind of elaborate on that. So for future reference, just so you know about that, because there was a problem recently, is when I first implemented the LLVM backend, almost all the tests were passing. I was a bit confused about that because I've written LLVM backends before, but typically I make at least one mistake or something in there. So I was a bit confounded. And then I was experimenting with more. And my first reasoning, though, the reason why, because typically when it just works, I'm sussed out typically, but I wasn't. And the reason is that what I thought might have happened was, oh, maybe I was generating invalid IR, but it was getting through because Clang doesn't validate the IR by default. So I tried it with opt. And opt, when it optimizes, there's a way I added to the lint flag where it checks for UB and something, which is very useful if you do nonsense because sometimes your IR will get through, it will work until you try to optimize, at which one you run into tons of UB and it just it ends up horribly. It crashes. It doesn't crash, but generates just nonsense or generates no code at all because it's UB. So, but opt warns about UB. It gives you an error if it finds UB. So that's nice for checking that your IR is being generated properly. So what I tried was, okay, I was testing some random case, and I found that the comparison case, which is supposed to return 3, returned like -3. It was being optimized to -3. And that was because I was sign extending I1s instead of 0 extending them. But the weird thing was, it was returning -3, which on my system wrapped around to like 253 or something. But the test was passing.
Oh no.
So that was when I knew it wasn't checked. The test handler was not checking return values properly or exit
Oh
codes.
no.
And there's a reason for that. Because on Linux, system does not return the exit code.
It
It
doesn't?
returns no. System does not return the exit code. It returns something that is called a wait status. And it's also what it's called that because it's also what's returned by wait and wait PID. And that has a lot more information than just the exit code. It also
Yeah,
has
that's
information about whether the process was turned by a signal, whether it exited at all, whether it's still running, what
which
the exit code
signal.
was if
Yeah.
it exited, and so on. And the exit code is not in the bottommost byte, it's in the second least significant byte. You have to shift it over by 8 to get the byte that is the exit code. And there are macros for that on Linux. You can actually check that out now in the test run. I fixed that now.
But I
We
can
can take a look at that. It would make more sense to take a look at that. And this is something you have to be aware of. It's a problem I've encountered before, so that's why I pretty much knew what the problem was pretty quickly. Yeah, run command does what you need to do to get a meaningful representation of what it means for a program to have succeeded or failed. So it does system, and then if it's on not Windows, it just processes, it checks a few things. For instance, if the process was signaled, what was the signal, and so on. So, and the process is succeeds if it wasn't signaled, and if its exit status is 0. That's the condition that you have to check on Linux. And if you scroll up a bit, this now returns an exit status struct because we have there's more to this than just an exit code. The exit code is only really valid if the process has exited successfully, whether or rather if it has exited at all and wasn't signaled, because then we have a term sig and not an exit code. Right?
Yep.
So you have to respect that, because on Linux, if you just try to use system, it's not going to work. On Windows, that's the else case there. You do fine doing what you did. That I want to explain. Yeah, this is this is a GCC thing, and Clang also supports it. It's Pragma Poison. Well, that poisons the identifier. What that means, if you use the identifier system anywhere after this, it will error.
So you
So
have
that
to go
means-
through run command. Yeah.
Yeah, if you try to use system, it will error.
kind of
If
curious
it's
now.
a function, a variable, whatever. If you try to use the word system as an identifier, whether it's a function, an identifier, a field of a struct, if you try to use that anyway, even if it occurs in a macro expansion, GCC won't let you. You'll see that. There you go. Attempted to use poison system. And that's good because we don't want to accidentally forget about this and use system.
Yep, we want to use run command only.
And this is a technique that I use very rarely, but I use it in cases like this where I need to wrap something that on its own is easy to misuse. And I've done the same thing, for instance, in my compiler. There's a function that adds an incoming value to a phi. That function is pretty stupid, though, just to checking. For instance, if the block it's trying to add the value for it ends with an unreachable, meaning it never branches anywhere, then if you generate that IR, the library will let you do that, but it will fail the verifier step and it won't actually end up generating code for it. So it will just crash sometime. It will let you do that, but it will crash. So what I've done is I've wrapped that and added some checks to make sure it actually just drops the value if it's not valid. And then I've poisoned the add incoming function so that I can't use it after that. And that was necessary because I tried using it recently and then I got the error and I was like, good thing I did that, because that would have caused another bug, because those bugs are horrible. It's like suddenly LLVM asserts and you don't know why what it did wrong, and then you see, okay, that phi is nonsense. And yeah, this was my solution. Then that's what I used here too, because in 2 months when we've forgotten about this, and you'll try to add something at the bottom, and then you'll use system, or I'll use system, and it just will tell us, don't do that, use this instead. So that's the point of this. Anyway, just wanted to explain that so that's clear now why this exists.
That's really cool. It makes me want to make a better way to replace a function. in the at the language level.
Actually, I sort of disagree with that because you wouldn't want to suddenly have nominally the same thing do something else. Because here,
Right.
poison system does sure you can't use the word system for it, but you also wouldn't want to because system does something else. You don't want to do what system does. You want to do more than that.
Exactly.
think
So
System 2 Electric Boogaloo.
yeah, so maybe replace was the wrong term, like wrap. So when you make a wrapper function,
Okay, sure, yeah, something like that, maybe.
make it possible where like you want to make the wrapper function the only one that's usable, and the one that it wraps is now like too low level to be used from now on. Or like,
Basically,
if that makes sense.
yeah, you're basically describing exactly this, something like pragma poison.
I mean, actually, it'd be even more useful just to be able to delete a symbol in a particular scope.
Oh, that's
And that-
also a good argument. Yeah, just delete
Ooh.
something. Yeah.
I like
Depends,
that.
depends on how you're doing modules as well, because you could just import your wrapper module, which doesn't import the symbol that it's wrapping, and then just
Yeah. That's how we
Right.
probably do that. For instance, if a module internally can use puts, but it doesn't export puts, so you can't use puts just by loading that module. That's what I do in source, and that's what I would recommend doing because you don't want to bring everything that a module needs into scope. That would be
Exactly.
So if your modules do that already, that's like 90% the way there. It won't prevent you from using the other one, but it won't be imported automatically. You'd have to have already explicitly imported it to
Yeah.
get to that point.
Yeah.
That's true.
Concretely, in this case, the whatever module we put something like system in wouldn't export the actual system. It will only export a wrapper like this.
Yeah.
That makes so much more sense. I'm getting it now.
Yeah.
So even though system is imported and it's an export, yeah,
Yeah, you don't have to export it implicitly.
it stops at that level. Yeah.
Yeah, because you have full control over the symbol table for each import.
Especially because the modules are compiled separately. So that module can link against system, but the other modules don't have to. They just link against this module because they don't use system, only we do.
Right.
So even for linking, that's not an issue.
Cool. Okay.
But yeah, this thing with like exit status is just something to remember. If you ever need to write cross-platform code that uses system, this is what you'll have to deal with.
Wife exited.
That's. I'm glad I'm not the only one that reads that. All I can read here is like wife excited. What am I reading?
Exit.
Divorced.
W stands for wait status. Yes. W exit, W signal, W exit status, and W. There's also W term sig that gives you the signal that terminated the process. I didn't do that here because we don't check for that. We could check for that, for instance, if we ever add something like a built-in trap or an int3, something that like calls into the debugger. On Linux, that issues a sig trap. So we could check that issues a sig trap if you want to be able to test for that. In which case, we do need W term sig. But we're currently not using it, so I didn't add it just to not like make this any more confusing than it needs to be.
Yeah, I think that's fine.
Because the entire wait status thing is already bad enough.
We've got an interesting chat from Ugworm, first time chat. I'm just starting to learn about compilers, so I'm curious. I wonder, why did you need to write a backend? I thought when you have the IR, you can use an existing x86, etc. backend without adding anything.
You got to turn that into something that an x86 backend could process.
Right. So I think their confusion is when they hear IR, they're probably thinking LLVM. So when you say IR, we have our own intermediate representation that we generate, and then that is basically then needs to be converted by our backends to be used by different target machines, if that makes sense.
Basically, we've implemented emitting assembly and machine code ourselves without using LLVM or any other library.
Exactly.
But we've now also added an LLVM backend. So we can also emit LLVM from the IR. And it's actually useful that we had our IR because typically, if you want to emit LLVM IR, even in text form, you need to build it beforehand in memory because you have forward references such as FIs. Blocks you can get around, yeah, and blocks too that jump forward. But because we already have that, what I'm doing is I can assign the numbers. You can actually look at that in code. Why am I even talking about this abstractly? You can just show that in code.
Where is
Where
it?
I'm doing in the LLVM. I forgot what it's called. The LVM.c thingy. LVM target. Just it's close to the very bottom, I think, in emit function. I think it's called. Up a bit more. Yeah, here's some. Hold on. Yeah, that's fine. We can function header argument types. We can go back down a bit. That's just special handling for types. Down. Further down. Yeah, here starting at line 664. We iterate over all blocks, overall instructions in all blocks, and we assign indices to them so that when we need to, for instance, emit a phi that contains that refers to values that haven't been emitted yet. Well, they haven't been emitted yet, but we already know their indices because we've assigned that already, and we can do that because we already have a in-memory representation that's close enough to LVMII, and that it also has phis and blocks in just the same manner to where that just works.
That's right.
That way,
Yeah,
we
right.
don't need to convert the in-memory R to in-memory LVMII and then emit that, because that would be tedious. Which is what you'd normally do if you compile directly from an AST to LVMIR without any other IR in between. So what you then do is you either use a library or write your own in-memory representation for LVM instructions, because without that it doesn't work. You need to resolve these forward references. That's the nature of forward references. As soon as you have forward references, you need two passes. You can't do it in one pass.
Exactly. Yep.
But yeah, we're assigning everything here and then we're emitting it.
Ugworm says, "Oh, so you're implementing LLVM itself as well."
Yeah, basically, that's a good way of thinking about it. I mean, it's LVM is very complicated and very big, and it would take a very long time to do that, especially if it's mostly just the two of us, and recently mostly Lens does. So
It's yeah. It would be another 10 years before we get to the beginning of LLVM. Deagle TG,
Something.
first time chat. Hello. Nix Craig waves and says, "Did you see Zig just had a proposal to move away from LLVM?"
That's interesting. I generally would consider that being a good idea for a production language. Simply because it's very hard to do all of the things that LLVM does, because it supports a lot of targets and also all the optimization and register allocation stuff. Like there's things in LLVM that people have been working for months, or for instance, there's a new instruction selector now that has been being worked on for like years now, and if a team of compiler writers are working on that for a while, then yeah, to reproduce that from scratch, there isn't really a good reason to write an optimizing compiler from scratch if you really just want to generate optimizing code. Like the only reason why we are writing a back because we want to write it back, and if our only objective was to really write a new language that could be used very effectively, a high performance language that could be used, now we'd only be using LLVM. Or maybe compile to GIMP or something like that if we wanted to use GCC. But the point is, we'd be using a pre-existing backend, because doing all of that from scratch is really hard, and it would take a long time until something like that could achieve the same maturity as a pre-existing implementation, be it LVM or GCC.
That's what I'm doing in my language. Fun fact, actually. But yeah.
So it's the main reason to have a non-LVM backend, and that's what some people do, and that actually does make sense, is for unoptimized code, because LVM can be a bit slow because it does a lot of things. If you just want to emit code as fast as possible and you don't care about optimization, you just want code now, then writing a backend from scratch is actually a reasonable thing to do. It would still be a lot of work, but it's not just a stupid thing to do. However, if you want high performance optimized code, then I would generally caution against doing that. And I'm not saying it's impossible, but it will take a lot of time. And the thing is also that if you spend 5 years implementing or 10 years implementing an optimizing compiler backend, you still need to implement all of the things LLVM already has. Where do you think LLVM is going to be in 10 years?
Right.
Like, how are you ever going to catch up? are going to catch up.
Well, actually, the approach that I took that made me not want to use LLVM is I'm not using SSA specifically.
That will
I'm
change
using
things.
VS Code with like
Mhm.
very aggressive, like sort of like a Monte Carlo simulation, I guess, to basically just like see the actual empirical behavior of the code for basically every single instruction.
And not using SSA makes it a bit harder to reason about in optimization passes, and I'm not terribly familiar with compiler backends that don't use SSA simply because the SSA invariant that a value can only be defined once is simply so strong that most people use it nowadays. I'm not aware of any like major optimizing compiler that doesn't use SSA.
Right. Yeah.
So I'm not terribly familiar with how a good optimizing compiler would work without SSA.
I mean, basically, you just have to just reason about the code like a human does. Like if you're trying to hand optimize some assembly, then it's possible for a human to do it. We use
Yeah,
some
but it's a lot more tedious.
right, yeah. But there is actually some things that are easier to do in a non-SSA form when you're closer to the machine instruction level. For instance, a lot of things to do with moves.
Sure. Well, yeah. If that's SSA where SSA destruction comes in. Once you get to converting to machine instructions, then SSA would be a hindrance. Yeah. At that point, you need to get rid of it.
Right.
Sure.
That's basically the level that optimization happens at in the language that I'm making.
I see.
That's really awesome.
Definitely a lot of work.
It's cool to see like different ways to solve the same problem though. Like the Movepiscator. Like
Oh god, yeah.
that's not a real tool, but it's still so cool to see that and how that's possible and
The Movepiscator, yeah.
Yeah, I think we did it. There's surprisingly
Oh
no
god, I forgot a comment.
You forgot what?
If you go back a bit and you scroll down, you'll see it at the beginning of, I think, there we go, line, too fast. 694, you have to put a comma at the end of that, and then if you put a trailing comma in there, Klangphone will actually put it on the next line, as it should. If you don't, it will do this atrociousness. So,
And technically this is all 4-space indented.
yes, of course it is. 2 spaces is an abomination.
Actually, 8 is.
8 is just like more spaces than code.
Well, actually, I use tabs, so they don't have any spaces actually.
What size are your tabs?
8. Yeah.
Oh god, that's horrible.
What?
Yeah.
Don't indent. Problem solved.
8 is well, I use spaces in the sense of I don't press space. I press tab and it inserts spaces.
Right. Of course.
And a big reason for why actually I used to use tab, but a big reason why I use spaces is because I format my code and sometimes I need to align some stuff these days rather than I used to. But the problem is if you align and I have my tab is 4 spaces, it's going to look completely wrong for someone who happens to use an 8-space tab. And that's why I don't like using tabs, because different people will have different tab size, and I want my code to always look the same no matter who's looking at it, because that way the formatting makes sense.
Well, I mean,
Like from a type point of view, that's
Tabs for indentation, spaces for alignment, master race.
yeah, exactly.
What'd you say?
Literally. Yeah.
The thing that I said the first time we had this discussion that you said was disgusting.
So like tabs for indentation, spaces for alignment. That's basically what
Yeah, that's the problem, is that if someone looks at your code and they have a different tab size than you, it will look just weird.
Well,
What?
no, because that's what the spaces are for. You tab for indentation only, and anything after an indentation is always a space.
Yeah, exactly.
So the only thing that changes is the level of indentation with tab size, but your alignment never gets broken.
I see what you're saying.
Sure, that can work if you do it that way. Yeah, that can work, but
That's the most compact way to also guarantee alignment stays correct on all tab sizes.
sure, that's something you can
It's
do.
hard to maintain because it's not a native feature of most editors, so I don't do it. I still use exclusively spaces. But if editors supported it better and knew how to do it correctly, I would do tabs for indentation, spaces for alignment.
I would still not want anyone to look at my code and have 8 space indent simply because some
Sucks if
things
they want 8 spaces indent.
sometimes if you have a lot of nesting that may look okay with 4 spaces, but it will just be completely unreadable with 8.
Well, that's kind
Sucks
of
for them. They can change their tab size.
if you have like
It's
7.
not that easy because for a long time it used to be that on GitHub you couldn't set your tab size permanently, and I'd always had to have to look at code with 8 tabs because that was default, and there was no way of changing that permanently for a
Right.
long time, and that was really annoying. So I don't do that in case there's other because I'm pretty sure there's other systems out there that suffer from the same problem where you can't just change the default too easily, or you can, but it's annoying. Or some people might not know or not want to do that, etc., etc. So I just don't want to run into that problem. Mike, I know that if I send my code to someone, or if someone else looks at it, they're going to see exactly the same thing that I'm seeing. So I
Okay.
don't have. That's why I use spaces, not tabs. I used to use tabs for a long time, but I switched to using spaces for exactly that reason, because it's more consistent. Because you don't have to worry about tab sizes at all, ever again, anywhere. It just works because it's a space. A space is a space. A tab can be something.
Space is space.
As for many spaces, I always do 4. 2 just doesn't look. I'm somewhat more used to it than I was a few years ago, but I still don't like 2 space in that. It still looks too narrow to me. 8 spaces is more spaces than code at that point. And I know there's people that do weird stuff. I've seen 3 spaces. I've seen 1 space indent
3?
before.
Oh my god.
Yeah, someone just pressing space once to indent.
I kind of understand 3
What? How?
because
3 aligns with if.
it's like
Wow.
it kind of makes sense. Like like he's saying, if happens, and it's like it's enough space where you can see this is clearly like empty and it's not continued. But it's-
Only works for if though, because that's the only goddamn 2-letter keyword in most
It works
languages.
with do.
What about-
do? Well, how often do you use do?
I don't use it like ever, but you said it was the only, and I'm going to find a pedantic counter example.
Okay, it's true. It's not the only, but it's the only one that people actually use somewhat regularly.
Said that.
The only one that matters is what I meant.
what about like is?
You
At
don't
the
use
beginning
is in a block expression, though.
Is as a block? I've never seen that anywhere.
Naturally.
Yeah, that just doesn't make sense. See,
So
this you lost me.
so my immediate thought was like structs, like comparing like node is a
Yeah, but
struct
then it's
with
not
like
the only thing.
int and blah. You're right. Then it's not the only thing, and the 3 space indent breaks down. So you're right. It doesn't line up most of the time. That's not a good reason. But I think it's just a good, like 4 to me is just too much.
So what I'm hearing
Like
is we need to
HTML.
change our indentation depending on what structure we're inside of. So we indent 3 times for if, and 4 times for for, and 6 times
Yes.
for while.
God, this is starting to go.
Yeah. You just indent to here.
It's just Lisp
Yeah.
at that point.
Beautiful.
It is Lisp. That is kind of how Lisp indenting works.
How Lisp indents. So for Lisp it works because everything looks the same, but it looks horrible for regular imperative code.
I don't know. This is the best code I've ever seen.
Yeah. And then, 4 naturally would be
4 is your regular
here.
4. It rhymes.
What are your standards then?
Yeah, and then, if this is natural. It's only
Else?
natural.
So in an if, you only go 3, but in an else, you're going to go 5.
For stuff like this, normally you'll see me complaining about how Clang format
even
does
farther.
all such things, but in this case, I'm thankful it doesn't.
And it's
This
actually
is how God intended us to program.
yes.
Well, it's easy to figure out how God intended us to program. Just look at what Terry Davis wrote.
Oh, you're right. You're right.
Oh.
Dude, that shit's still cool. Nobody can take that coolness away.
Nix Craig says 3 spaces is surprisingly nice, but I just use the language default Beaver Fever says, yeah, I like 3 hover. I tend to use 4 most. You could always add and TS equals 2 to the URL, lol. Oh, that's probably the GitHub.
I know you can do that. That's what I used to do, but it's horribly annoying. If you have to do that every goddamn time you navigate your file, that gets annoying. It does. I've done
You're
that
right.
too many goddamn times.
Just write a browser extension that adds it automatically.
God, duh.
Good God.
What are you,
Simple as.
pleb?
Also, if I'm on some server where Vim isn't configured to my liking and I need to look at some code real quick, it's like halfway into the file.
Damn.
There's nothing more on the screen because it's just indented 2 levels and suddenly like half the screen is empty because it's just white
Since
space.
you're so good at formatting text, fuck, I've already forgot the word. It's too late. You should write the book on how to not be happy ever.
I'll stick with formatting. I think that like a comprehensive guide to LaTeX and that would probably have the same content or at least similar. Because if you really need to like delve into LaTeX in terms when you know how some things work, you will like be
Typesetting, that's the word.
annoyed by certain things like the kinds of bugs you can encounter in LaTeX are fascinating because it's things that you never will have conceived of. Because how most people think about how lexing works is, oh, you have a character and the character has a character code, right? It's not how LaTeX thinks about it. In LaTeX, every character has 2 things: a code point or character code and a category code. And if you have 2 characters, like 2 A's, and they have different category codes, then they're different characters. And if you want to check, if you have an if next char check that checks if the next character is something, then if the cat code of that character is different now from when that if next char was passed, when you define the command, it will be false because it will have a different cat code. Have fun debugging that if you don't know about that. These are not like fun errors. These are things like you'll stand there, you stare at it for like a few hours, and then you figure out, oh, it's because when you write def and you specify a terminating character in there, when the def is passed, that character has a certain cat code. But when it's then encountered later on, it has a different one. So that's why it doesn't find it and it doesn't work. And the only error you get is some stupid thing like a unterminated argument list or something. Something that isn't helpful at all.
It's like the missing semicolon error.
Something like that. It's like missing semicolon, but imagine that suddenly you could do something in the code that suddenly makes semicolons no longer be semicolons. And you have to write the Greek question mark instead to get a regular semicolon.
Didn't we have that earlier where like something failed to save properly and Lens had to put 2 semicolons to get it to go away?
Yeah, something like I don't remember what. Like that
I
was
don't
just
remember what it was either.
But
Like expected semicolon. Yeah, semicolon.
That's right.
But you can actually look at like the thing I wrote for highlighting source code. There is a comment in there that I'm not sure if the comment really refers to that just now, but it is because of that issue sort of. There's some really weird things you need to do to get it to pass properly. It's not unintuitive because you have to think about how things are passed when you just define commands, and you can change the worst thing about LaTeX is you can change the way it's passed, and Lex effectively isn't really a Lex, it's just a parser. It's not a separate thing in LaTeX, but you can change the way the language is passed by running some macros. So the language can change how it needs to be passed, and that's why it's basically impossible to pass LaTeX properly without evaluating it. Like you can't really pass LaTeX. You can't without evaluating it.
Right.
Because of category codes may be changed by the program in rather horrible ways. Like you can look again. You can look at my package for that. It's like some of the code in there is just horribly incomprehensible if you don't know what it does.
Beaver Fever says, "What is the icon in the left gutter that shows up for errors? Is it a nerd font icon?" So presumably that's like this thing in the left. This is called the fringe in Emacs, and those are actually defined in code. In the source code of Emacs. So it's actually a variable defined in the source code, and it just is bitmaps. It's literal bitmaps of fringe symbols. And these are all built in to Emacs.
built-in icons in C
Yeah,
naturally.
yeah, they're like
See, this is what
bitmaps.
you get if your language doesn't support embed.
It is true. But yeah, so like the things over here on the right where that's wrapping the line, this is one of these as well, the right curly arrow. Right.
Well, that makes sense.
But yeah, so these fringe icons are very specifically just bitmaps, like literal C arrays.
Hmm.
But they show up from something called FlyMake, if you're interested, which Egglet uses internally. So just use Egglet and it'll happen. And then Tesla Puts says, compiler from scratch for fun, how could I not click, lol. Hey, I'm
We
glad
had
you
a very
joined.
fun discussion about how 2 + 2 = 4 a while back.
A literal 2-hour discussion about it.
Not even about how it equals 4, just about how to calculate it.
Yes,
The philosophy of 2 + 2.
yes, the philosophy of 2 + 2 = 4.
The equals 4 isn't even important. Just 2 +
Yeah.
2. We got stuck there.
We even talked about cases where 2 + 2 might not equal 4 due to mathematical bugs that
Yes.
we were then corrected on would never happen in the 80s. They'd have to be in the 90s.
Because of the Cold War.
Impossible.
There's so much Lenser lore.
I will say it is the first time I've had a discussion about how 2 + 2 about 2 + 2 in general. Yes.
Plenty of discussions. Specifically about 2 + 2.
That's incredible. I've had like a joke discussion where it's like, you know what I mean, where somebody's like, oh, but what if, so 2 + 2 = 3, and they like keep getting it wrong on purpose.
Oh,
Mm-hmm.
And then I've had ones where they like do the tricky math thing where they like,
Yep.
well,
You
what if,
obfuscate your math step by step until you make a single decision that nobody understands,
Yeah,
and
until
it's
it-
wrong.
or some like incorrect proof where that
Mhm.
involves a 0. Those are always fun.
all right. Yeah. We merged a PR. We broke my module code, so that's good. I'll be able to fix that.
Ugh, fuck.
At this
So
time
we
I'm
can
gonna
do LLVM IR now.
Oh, that's right. We now have the capability to generate LLVM IR. For example, do I still have it?
Do a complicated one. Do we have anything more complicated than Rule 110? Or something else, maybe? I don't know.
I think Rule 110 is our most complicated program so far. Other than like SDL, but that's linking stuff. That's why that's
isn't
complicated.
it 110? I'm pretty sure it's pronounced Rule 110.
So it really depends.
What?
I mean, it's like saying, how do you pronounce like
Git?
1,000?
GIT?
Like no, like the number 1500 as one decimal number. How do you pronounce that?
1550. Or
1,500?
1,550.
But what about 1500?
I
Yeah,
knew
1500.
That's totally an abomination.
I love
Right.
doing XX100.
Yeah, I definitely see what you mean.
It was the influence for my number system in Koskan.
I think most people would say 1500, yeah. At least I would.
It's just shorter.
Mhm.
It's easier to say.
And the weird part is it's how you parse the number as well, because you see the 15 followed by zeros and you're like, oh, 15 what? 15, and then you see 2 zeros, which is 100, so then it's like, oh, 1500.
That's a weird thing because some languages do it the other way around, but at least for the decimals, like they'll say for instead of 42, they'll say 2 and 40.
Yep.
Right,
What
right.
about
For instance,
do you parse 150 as 50 tens?
1510. Well, in that case, there's only 1 0, so it's a lot easier to tell at a glance what it is.
154 would be 104 and 50. So it's just the decimal and the tens and ones place that are swapped.
Well, at this
At least
point,
in German.
I would feel that I would parse it as 1 and 50. So I'd say 150.
I say
Mhm.
150.
What
No,
changes
what I'm
when you
saying is that the languages that do say something like 2 and 40, they only swap the ones and tens place. Like
I
Oh.
like that we're
basically-
having two different conversations, the three of us and then Eternal.
It's very interesting. Actually, the like the actual Rule 110, you like parse the digits of Rule 110 in like I guess if you take the number 110, like like 110, you turn it into a 8-bit binary number, then that's essentially the rule set, right?
Okay, yes. You can
Hmm.
describe the rule set using the 8 bits of the decimal number 110.
Right.
But it's kind of confusing because it has to do with a 3-bit window, and
Right.
what those 3 bits are will tell you the index into the 110 that you need to actually.
Right. Yeah. That's
So
right.
so you either and or based on the bit index of the number. It's kind of confusing.
Well, it's like basically whether or not the output is a 1 or a 0.
Right. So everywhere you see and not, then the output would be like this and not or and not or and not. That's literally the binary pattern of 110.
Exactly.
And it's just kind of encoded in the state because the number will tell you what new number to get. It's basically a lookup table.
Right. Yeah. Exactly. That's precisely what it is.
See, the optimizer is apparently able to figure out what all this is doing. Because it just,
It does
some
this.
Yeah, Clang, the thing about this is also Clang likes unrolling loops a lot. It does that a lot.
RIP code size.
And a lot more than GCC.
Hmm.
It will inline. I think GCC like stops at 60 iterations. Clang goes over 30, like 32 sometimes or more.
Jesus.
Then again, I've also seen GCC. This was funny because I was testing memcopy implementations, and it was testing it in a way that it could inline it. And for suddenly for like a size of a few kilobytes or whatever it was like 10 times as fast as glibc or something. And I discovered why. It's because the array size was known at compile time, so it had unrolled like the 256-bit AVX vector copy instructions like 50 times or something.
Yeah.
It's just 50 v move DQ D whatever in a row.
Yep.
Just like 300 lines of just like SSE instructions inlined into the function. So yeah, that's why it was faster, because it knew the size. It just unrolled the damn thing.
It's a lot like so for GCC technically has usually like faster optimizations, right? Or more aggressive at the highest level, like O3.
So that depends on the last benchmark I know isn't really up to date, but from what I know is that Clang is more aggressive with optimizations. For instance, Clang like O2 at O2 it already starts vectorizing a lot more to where GCC only does that at O3. And also for GCC, like march native makes a bigger difference for GCC than for Clang. Clang is already more aggressive, whereas for GCC, if you do O3 march native, then it starts being really aggressive.
I see.
Clang, at the same level, Clang does more than GCC. But if you're turning up to the max, the results should be mostly identical. Though Clang, I've seen Clang unroll loops more than GCC. But I tested this recently, so if they've changed something, then that may be different now. And this changes all the time. So
have
but
they?
I want Clang to be more aggressive with optimizations.
So Clang has more optimizations enabled at lower levels of optimization.
Yes, I think so.
If that makes sense. Whereas GCC, once you do get to the final level of optimizations, everything does get enabled, and it's the same aggressiveness as Clang. But if you go to down to O2, there will be way less.
I think Clang is still more aggressive if you turn it up to the max.
I
There
see.
are some differences, but
So
they're
then-
not identical.
But performance-wise, I've heard that GCC can sometimes win out.
Sometimes, yeah. Sometimes, sure.
If they're less aggressive, how does that work?
well, you're saying sometimes. What I've heard is that in my that Clang, which is typically better at optimizing than GCC, so that varies all the time.
I see. So that's probably a per program type of thing.
Yeah, and also per release, probably like some releases of GCC are probably going to be slower than some of the releases of Clang and so on. It's like, from the most part, unless it doesn't matter. Like if the performance differs drastically between Clang and GCC, that's probably a bug in whatever compiler that doesn't optimize it properly. Because they're both open source compilers, they shouldn't be drastically different from one another.
That makes sense. We got a new chat, first time chat. The real move is to use rustc. Ban that guy. Someone ban him. Get him out of here.
Have you given either of us mods?
I can do that if you want me.
No, I'm joking.
Also, we were going to make a poll early, I think.
I
already
kept
forgot what
getting
the poll
Twitch
was.
errors. They wouldn't let me. And then I tried to make someone a moderator and it gave me another 503 service error, and I got annoyed with it.
What? Still, 503 what is 503 again? No, 403 is forbidden. What is 503?
It's anything over 500 server error.
Yes, I know a 500 is an internal server error, but what is a 503? I don't remember that.
Oh,
Service unavailable. Okay, that's what it was.
that's what you did. You did don't say that.
Yes.
But yes, generally 500 is internal error. 400 is bad request. Like 400 error codes.
Yeah.
I know I know a lot of them now because I've had to do backend stuff in web, so implementing web servers and such. So I know my way around error codes now, but I typically don't know all of the 500 codes because I just do the most used ones are 500 and 502, and 502 is for proxy servers because that means bad gateway, and you're not going to issue that yourself because you are the gateway. So
it's funny that when you said 502, I immediately, in my head, I could read the words 502, bad gateway. And I was like, why do I know that? Like, I've read that somewhere.
You get that all the time. If a proxy server is misbehaving, for instance, if we have a 502 page, if I were to shut down the Nginx server, then Nginx would give you the 502 page.
Nice.
That's just what a proxy server gives you if the server it's supposed to redirect to doesn't respond.
That makes sense. Tesla
And
he said Rust, sue him.
The other common one is 500, which just means internal server error. Like with the 400 errors, there's a lot more variety. For instance, there's like 400 is bad request. That's the most generic one. 401 is not authorized, and 403 is forbidden. Those are different because not authorized means you need to log in. Forbidden means even if you were to log in, we're not going to let you access that. So 403, no chance you're getting that. 401, you might get that if you like authenticate. 402, I'm not sure what 402 was actually. Let me look that up. What was 402? I should know that. 402 payment. Okay, that's what I don't know. 402 is payment required. Okay, I've never seen that one actually used, and apparently it's experimental, so that's not surprising. Then there's 404. Everyone knows that one. That's not found. That's if you can't find the resource. And those, I think, are the most common ones. Then there's, I think it was 427 is rate limited. So that's when you're making too many requests. No, 429 is too many requests. And obviously, the many people's favorite one is 418. I'm a teapot.
Wait, what?
418. I'm a teapot.
You're joking.
It's used by coffee machines.
No.
By teapots to notify that they can't brew coffee.
You're joking. That's not actually a thing.
This is
Yeah,
a thing.
It's right there.
It's got an RFC. Oh no.
Yeah, it's got an RFC. It's well defined.
There's a coffee over ice scheme.
You have got to be kidding me right now. I had no idea this actually existed.
It's 418. I'm a teapot.
Humanity is at its all-time low.
What do you
It's
mean?
pretty old. It's from the 90s. If you look at the header, like there's a date there. It's from the 90s.
1998.
Oh my
Yeah.
god.
I'm a teapot. You know, you've got the the get, the when, and the clear response for I'm a teapot.
Mhm.
Oh, that's incredible.
I think you missed the request type too if you scroll up.
Did I really?
Yeah, there is one more that I know.
Oh, prop find.
Oh, not that one. I wasn't talking
What?
about that one.
If a cup of coffee is data, metadata about the brewed resource is discovered using the prop find method.
I'm pretty sure there's another one somewhere.
Who's Dave?
If you scroll up a bit more. There we go.
The brew
211.
method.
Hmm.
No, there's literally
Yeah, you can use post, but post is deprecated. It says so in the second paragraph. It's deprecated.
it must accept brew and post. The use of post for causing action to happen is deprecated. Coffee pots heat water using electronic mechanisms. Really? So there's no fire, thus no firewalls are necessary. Oh no.
What? That's so stupid.
But post may be a trademark. The brew method has been added.
The hypertext brewery control.
HTBCB.
Also, this was in 1998. I'm not sure if electronic coffee pots were connected to the internet back then.
No.
Right, this was even weirder.
Yeah, gotta love like the hard-coded milk and syrup types.
Hard-coded
Vanilla,
milk and
almond,
syrup type.
raspberry.
Yeah, addition type, milk type. It's part of the grammar.
Whiskey, rum, Kahlua.
Who would who's putting Kahlua in their fucking coffee?
Dude, it was 1998. Those were different times.
They had to deal. Okay, they had to get through it.
It was almost Y2K, man.
They,
Oh, yeah.
Programmers needed the energy.
they almost had to write software again.
Love the media type.
Modern coffee pots do not use fire. Properly disappointed there's no option for Baileys. This is as close as you can get to Baileys without getting wet.
And I'm pretty sure, yeah, this defines 418 somewhere.
Yeah, I'm a teapot.
There we go. It also explains what it should be used for.
The resulting entity body may be short and stout. That's so stupid. Who wrote this? L. Massenter. Larry.
Larry.
Of course, it's a Larry.
He's got a PhD, apparently.
He wrote his thesis in global program analysis in an interactive environment in 1980.
God, I love not being able to access papers.
QLisp from 1976. Ew. Okay, I'm down a rabbit hole. Larry, thank you for giving us this.
Some people actually use 418
Oh.
to like return some if it's like some nonsense condition or just for testing internally.
Which actually helps a lot. Yeah, because if you get 418, you're like, oh, this is a testing thing. This is not like
Yeah.
serious.
You're making me want to start returning 418 seriously, though.
That's your new success return.
I've got a web front end for a tool that I'm about to be deploying places. I might just have some 418s now.
Mm-hmm. I'm currently writing or implementing a web server in C++. Well, not from scratch anymore because I don't want to deal with any of that anymore. After writing far too much URL passing code, I've decided that I actually do not want to pass URLs anymore because that's another thing I'll talk about.
I've got
proud of
one
you.
that I have access to in C#. We bought the source code from another company, and technically I maintain it, even though we're deprecating it now. So that was fun. That's how I learned how to do web server stuff. Really old C# code.
I
Gigi
see.
says, I wish I was a teapot.
Well, it's the intent that matters.
What is there a 420 RFC for status code?
420 status code, I think there is. It means no, there isn't actually. Interesting.
Well, we
There's
know
a
what we have to do.
There's a 421, which means misdirected request. Is there a? Yeah. But no, there's no 4. There's also no 419.
That's interesting. We should call that the bicycle response.
Hmm.
It's about time someone made a coffee pot operating system.
Oh god, there's also some really cursed ones like 508 loop detected.
Oh dear.
You've confused the server, but not to the point of exhaustion.
Yeah, that's typically if you run into weird situations where you have redirects that direct back to themselves or something like that, where it just keeps redirecting forever. Something like that, where the server just decides no, enough. But that's rare. Those are rare. Like, this is a rare card. I don't think I've ever seen that one.
I want to collect every status code like a Pokemon. Gotta catch them all.
That's right. That'd be fun to have an...
Create a toy web server to teach people about status codes, and the goal is to get every single status code.
Yes.
Little hacker playground.
Good luck with some of those, because some of these are like 100 continue is rare. That's something if you get that, like, I mean, I guess you can. I think most servers will probably respond, but it's rarely ever used because it's like a check to make sure that the server is willing to accept a request of that size. Like you send a second request before testing, and then there's some, like, the 100 codes are rare. I think either 100 or 101 is used to upgrade to WebSockets. But that's about it for the 100 codes are rarely ever used. The most common ones are the 200, which are like success. 300 are redirects. Those are the most common ones are like 301, which is a permanent redirect. And also I think 303, 302, I think is found basically. That's the same thing, but not permanent. So the server doesn't the browser doesn't cache that, whereas 301 it does cache that. And 400 are client errors, 500 are server errors.
302 found in redirect. 402 payment required is another fun one. There's an unofficial Twitter extension that adds a 420 response code.
Interesting. What's like the message for that one?
I don't know. That was GG in chat.
Yeah, 302 is found. Yes. Oh, and what was it? Was it 3? The sum of 3 or 4, I think it was. Yeah, 3 or 4 not modified. That's an important one because you don't want to. For instance, if you have a website with a bunch of like the images that don't change often, you don't want to resend the images over and over again. So what the server does is you can send a tag along with it, and the server will send back the tag if it requested again, and you can then compare that with your version on your server. And to see if it hasn't changed, you can instead respond with a 3 or 4 that tells it use the cached version. So that's not modified.
So it looks like Twitter used to return 420 for too many requests, like rate limit, but now they use 429 for their V2.
Which was supposed to use 429.
Yeah. Makes sense. There's yet another RFC to describe it.
There's too many RFCs.
There really is.
We're soon going to be at 10,000 because we recently had like recently I think that was last year or a few years ago, where like new RFCs for HTTP, HTTP2, and HTTP3, those were like in the 9,000s.
Right.
HTTP 9,000 something. and whereas the original TCP RFC, too many letters, goes back to the 70s, and that's like 700 something. That RFC.
It's kind of weird that only 10,000 things. Humans have like done less than 10,000 things in that time.
Well,
There's
you
been
don't know
billions of humans.
about thing.
It is. I guess it is niche.
Yeah, it's mostly just for internet standards, even though an RFC isn't officially, it's like a request for comments, not supposed to be called a standard, but yeah, it sort of is basically. So yeah.
411 is quite funny.
Yeah. So if you don't have a content length header, and you might say, "Oh, why do you not have a?" That doesn't make sense. Why would you not have a content length header? Well, chunked encoding exists. Also, that's fun. That's fun when you need to pass requests because chunked encoding exists. You support that. It's like it's pain. Just passing HTTP requests is, I mean, it's better than passing HTML, but that's not saying much.
Right.
It's just passing in anything web related is just horrible.
I
H-
Web
agree.
is horrible.
Password is so fault resistant, and HTML and HTTP because URLs are just horrible.
URLs are kind of like addresses, like street addresses. Like they're so cursed. You can have two in the same city that are exactly identical but go to different places.
Well, with URLs, it's worse because you kind of two that different URL parsers can disagree on what constitutes a valid URL and how it's parsed, and somehow that is okay because there are two conflicting URL standards. There's the RSC3, I think it's like, what was it, 3842 or something? I remember what the number, 3000 something. That's the like official. That's the RFC one. That's the older one, and then there's the WG one. They also maintain
Right,
like
right.
the HTML spec, and that one is different, and that's fun because you end up with two. If you take two different URL parsers, chances are you're going to find a URL that they disagree on, even if they claim to implement the same spec. It's horrid because URL parsing is just pain with so many horrible edge cases. And it's not like the easy edge cases where, oh, you forgot a comma after HTTPS. No, it's cases like, is a double colon a valid URL? Well, it's because that's a valid
Empty
IPv6
schema.
address, right? And depending on what standard you use, it may or may not be.
So cursed.
Horrid. And you remember that thing with, what was it called, the log4j thing? Guess how that happened? Because they were using
URL parser.
different URL passes internally. One for validation, one for actual parsing. That's how that happened. So URLs are if something goes wrong, it's URLs. There's also things that are unspecified, like what if you have duplicate query parameters? Do you keep the last one? Do you keep the first one? Do you merge them? What do you do? There's no
That's how we can implement 2 + 2.
Oh my god.
If you have question mark q equals 2 and q equals 2, then q equals 4.
No, that would be 22 then, probably.
No, we're doing 4. It's
Oh.
got to be complicated.
So much HTTP lore. Seriously.
This isn't even, this is just like not in depth at all. It's just horrid, all of it. Web devs development is so jacked, so much jack, it's horrible.
It's true. Does anybody have anything to plug? Where do you want people to click on or go to?
I don't think I have anything, but join the Discord.
Nothing at the moment. I'm working on it.
Okay, well, stay tuned in the Discord. Come ask these people, Local and Eternal and Dwyer, what the hell they're working on and how it's going. Or just come join and they'll keep you updated.
Oh yeah, you'll see so much.
We got a lot of work to done today, didn't we?
We got so much done.
Mm.
It was a very productive day.
Yes, very much.
But yeah, if
We
you
now know that 2 plus 2 is 4.
We
And
learned that
exactly
2 plus 2 is.
it.
Period.
Yeah.
I learned
Or
2
rather,
plus 2.
to put it differently, we know how 2 plus 2 is 4.
Everybody asks what 2 plus 2 is, but nobody ever asks how 2 plus 2 is.
Why 2 plus 2?
Oh, that's so good. Be sure to join the Discord. You can also get announcements every time I go live. Join the VC and be part of the next stream, possibly. Ooh. Gigi says, I didn't get shit done today. Glad someone else did. No,
we
we're
didn't
just,
get you done.
we're joking. We didn't get anything done today. We had fun, though, and we learned a lot.
I have tech installed. I can do tech now. That's what I did.
Hey, that's actually a lot.
Turns out I did it months ago and I forgot. So I actually didn't do that.
That reminds me of It's Always Sunny moment where Mac keeps saying that like everything is because of God. And
Mhm.
they're like running out of beer, and then they finally find like this old case of beer that Frank bought 6 months ago.
Mhm.
And Mac sees it and goes, "A miracle! God saved us!" And Dennis just turns to him and goes, No, God not provideth. Frank provideth. He bought the beers.
Mhm. Yep.
It was so good.
Frank provided.
Frank provideth. That would be a good t-shirt.
Thank you, Frank. Praise be.
In Frank we trust.
That would be awesome. A whole merch line just based on the character Frank from It's Always Sunny.
In the beginning, there was Frank.
You can make a religion out of this.
Yeah.
I say that all the time.
All you need is 3 followers.
See, it's actually the same kind of thing. One of my friends sent us a video of basically that contraption. It's been done before, but he was so proud of it. It's where you squeeze the bottle and it fills up a perfect shot
Yeah.
in the lid of the bottle. And he was like, guys, I did it. I made this. And I was like, I can make a religion out of that. So I started, rewriting the Bible, but I called it the Grible because his name started with a G. And I was just talking about in the beginning there was Garrett, and he did this. He separated the alcohol from the not out. It's shit like
Oh
that.
god, that reminds me. Agma and a friend of his have this thing called the Gambian Holiday Week here. That we are eventually going to refactor to move that to Dog, but it's still up on like the old side. It's brilliant.
Mm.
Also, Nix is talking about PHP for pre-processing text. No, that is cursed. Don't do that.
Unless you want to do that, in which case do that.
Good luck with that. Good luck with that.
One time I tried to use PHP. I haven't recovered. I'm still trying to use it. I still can't figure it out.
Really early on.
I was gonna say
bad at it.
PHP is like Perl but scuffed, but that's wrong because Perl but scuffed is Perl. Not sure if I've shared this here before, but like 93% of paint splatters are valid Perl.
Oh my god.
And like this. Yeah, someone. And there's like this one. Hold on. I think I have that in my memes folder. It's too good.
Memes.
Where's the
Memes.
thing? Oh, I'll just look it up again. I'll find it.
Oh, I've made a mistake.
When we do eventually close stream, by the way, Discord for everybody.
Hey.
Oh god. Yeah, there we go. Oh, there's like one. Oh my god, it's so goddamn slow. Why does it take ages to load a PDF? Oh my god, that is
PDFs are garbage. I hate
8-page PDF. Oh, it takes so long. Okay, yeah. Hold on, this is brilliant.
Tesla puts this better than Java.
Okay, there's 2 parts to this. This is the first part. Hold on. Where's the thing? Here. I'll put it in the BC chat.
Figure 6 represents the string which by pure coincidence happens to accurately represent the author's verbal reaction upon learning that unquoted strings were a feature intentionally included in the Perl language.
Mm.
And this is part 2.
When Perl is run with the -w flag to enable warnings, it does helpfully inform the user that at some point in the future, the Perl developers will most likely pick as a new reserved word.
Mm.
Oh, that's so crap.
A string without quotes in Perl.
Yes.
Oh my god. Whose idea?
And this here. Jesus Christ. This language.
The Perl program illegal division by 0 at tempquine PL line 1, when saved in the appropriate location, outputs illegal division by 0 at tempquine PL line 1. The reason for this behavior is left as an exercise for the reader.
That's so bad.
So good. Anyways, yeah, thank you all, everybody, so much for watching. Be sure to check back more for more philosophy streams like this one. Like this one. No, programming streams like this one. And eventually we'll probably write code at some point.
I've got one that's somewhat relevant to compiler design.
Let's do it.
This is the last one for now, at least for stream. This is somewhat relevant for. Oh, they don't. It's entitled. The title is "Programming Languages If Language Designers Did Drugs." That's the title
Inline
of the
assembly for JavaScript. Yes. Yes. So good. Okay, go check the description. There's lots of links to click. Check out the projects we're working on. The compiler's making great progress. We now have an LLVM backend, which means we support a whole bunch more machines and targets and stuff like that. So that's great. Come work on the compiler. That'd be cool. And check out everything that's happening. We're going to be doing a lot of stuff soon, so come back here. Anyways, bye.